Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello everyone, thanks for joining and welcome to the WeAreDevelopers Container Day. My name is Sead and I will be your host for this afternoon. We're looking forward to 4 interesting talks about containerization, serverless, GitOps, Docker, Kubernetes and much more. Keep in mind that we already have also scheduled our next events too, so if you want to join the Python Day in 2 weeks or the .NET Day in 4 weeks, please check out our website on wearedevelopers.com/live and RSVP to the upcoming events. If you are watching us from YouTube or from Facebook, I would advise you to switch to wearedevelopers.com/live and join the event from there, because then you will be able to participate in the Q&A session. There you will see a Q&A tool right besides the stream. So before we start, we want to drive your attention to our code of conduct. In short, it means we have to be nice to each other and treat everyone the same way as we would like to be treated ourselves. Therefore, we have prepared a short video for you. Okay, now it's time to introduce you to our first speaker, Marton. Marton is a senior software architect and will talk about Cloud Run and the rise of serverless and containerization. So, welcome to WeAreDevelopers, Marton. How are you doing?
Hello, welcome. So, actually, I am doing great. It's hell of a last year, but it's glad that we are here and actually changing ideas, what's on the market, what options we have on this business, and to see latest features that are added into the containers and into the serverless world.
Okay, perfect. Marton, where are you joining us from?
I'm Hungarian, but currently I'm in Romania, so I'm joining from the middle of Transylvania for folks that know where that is.
Okay, perfect. So, Marton, I don't will take any more of your time, so I will get out of the way. The stage is yours.
Hello. So we are here today on have some, let's say, either winter or spring. Where are you from? So it depends on the weather. But let's talk about technology, and let's see what we are here today for. So it's Container Day. And my speech will be about the rise of serverless for containerization, which is an awesome topic to see. And there are some polls out there, so make sure that you check out WeAreDevelopers/live, where you are able to actually ask questions and vote on the polls as well. And I'm monitoring those as it goes, and in the end there will be a Q&A session as well. So let's start. So I'm very active on Stack Overflow. I answered a lot of the questions for brands, various topics, and I got into the GDE Cloud Developer Expert in Cloud Technologies in 2016. So in the last 5 years, I was actually monitoring and using all the new tools that come to the market, the rise of containers, the serverless, Kubernetes, and all kind of things. You can find me on my Marton Kodok stage names and also with Pentium 10 on GitHub and Stack Overflow. The slides and this presentation will be available on SlideShare right after this talk. So let's talk about our agenda. We will see what is serverless, what are the pain points, how Cloud Run brings serverless to containers. We will use a demo. We will see practical use cases and conclusions as well. Hopefully that will be useful for the audience, and some people will be able to learn more out about this, let's say, nowadays part of everyday developer lives. So just a quick introduction. What is serverless? Serverless, I would say it has an operational and it has a programming model. Now, what we already know that operational model is when you don't need, let's say, sysadmins, no infrastructure management. You have out-of-the-box security. Some of the securities are even managed if you choose certain providers for running your serverless production workloads. And there is a different paying model, like cost model, only pay for usage. It means that you can have a bunch of services which are running at minimum or scaled down to zero. For developers, which I am addressing mostly to developers, it means that from microservices, it has shifted into a service-based solutions. You combine multiple things in order to reach out the maximum scale of the application. And it's event-driven, a concept that even I say that it has new things that you can connect a lot more things than in the past 10 years. There are a lot of bridges now around the services between the cloud vendors, different cloud vendors, and also premise and the cloud as well. And it's open. So it means that you can bring your own tools. You can see what's actually, let's say, what's actually happening inside the world, like you can use latest updates and so on. So let's dive into more practical example. There is a study run by Brett at Serverless Days Milano, and this study shown a couple of pain points. Mostly, let's say that cold starts are the most influential problems that people raise when they talk about serverless. On top of that, there is the vendor lock-in and some others like billing or organizing code and those kind of stuffs. I want to address firstly, like how Cloud Run have addressed some of these pain points. Next, containers. In 2021, I would say that nobody needs introduction to containers. Basically, the key ideas today about the presentation is that you can bring your binaries, you can have any library, you have an ecosystem of the base images, and you can combine these into containers. And you ship your code using the containers and also with CI/CD tools. So, Cloud Run, bringing serverless to containers. It's an awesome product, and let's see why. So you are able to actually meet certain production happiness here. Cloud Run lets you to go to production in seconds. And it's natively serverless. It means that it runs on different architecture. either in the cloud, on-premise, or even on Kubernetes. And you have one experience thanks to the containers, and you have it there even in the testing environment, in the stage environment, also in Cloud Vendor 1, in Cloud Vendor 2, and all these kind of things combined under the Cloud Run service. So what kind of compute options you had in the past and how Cloud Run integrates to this? If you are talking about, let's say, Google Cloud Platform, where Cloud Run has a managed service, so you can see here that you have the cloud functions. As we know, it's only a function and it's actually source-based. It's great for HTTP and events. And you are able to actually address those kind of functions based on the source that you give it there. Then there are the applications, which is App Engine. This is also source-based and it's a full app, but it has some limitations and different cost model. It's more like a VM on steroids. Now, there is Cloud Run, which is actually not source-based. It's a source-based, but it's container-based. So your source is being packaged into the container. It's great for every HTTP and async jobs as well, because it can scale down to 0. And of course, it has a bunch more benefits inside the business model, like cost and everything else. So we are here to let's see what is Cloud Run and run a first demo. So I'm going to switch to my IDE, which is actually VS Code. I'm zooming in a bit to have you at. So I prepared for you a couple of examples. We are here in a Hello World example of a Node.js product. And here we have just a basic index file to print Hello World. What we are going to do is that we are going to launch a command, which is gcloud beta run deploy and demo. This is the service. Deploy WeAreDevelopers, something we can have here, and the current folder. The current folder holds a Dockerfile, and an entry point where the command will actually launch it. So when I'm doing this, the first option which I get into this interactive mode is that where I want to run this Cloud Run environment, under which environment. You have here opportunity to actually choose NTOS deployed on Google Cloud, or you can have on VMware and also in your Kubernetes environment as well. Now we are going to choose Cloud Run fully managed by choosing the one. Yeah, one, hold on. Invalid resource name, yeah, sorry. I need to change because I have that there. So one. Then I'm asked the region where I want into the cloud. I'm choosing US Central. And then I'm asked if my service will be accessible to public or it will be a private service. I will answer yes, because I want to be part of the public. Now, what's happening in the background? In the background, the sources are shipped. So effectively, the folder which I have, I didn't prepare any ignore files here, but you can prepare ignore files in order to ignore some content. It's being shipped, and there is a service behind the cloud build service that actually builds you the container. You are able to monitor the logs, for example, using this URL. And once it's done, you get a revision and also a deployment. While this runs, oh, it's already finished. So we have a URL here. You see that every application as it's deployed gets an URL. It's HTTPS. I can click it and open it in the browser, and you see hello world. So this was the first demo to actually show you how easy it is to actually deploy when you have a folder, a Docker file, and a service. Just to remember, I run the gcloud run deploy demo 1. And here for your station, you need to set up the gcloud utility. and also connect it to a project. As I use VS Code, there is a platform picker or project picker extension, which is here on the status bar. It's quickly easy to actually change projects as well. Disclaimer, it's being created by me, so it's one of my extensions to VS Code that you can actually use. Now, if we are having a session here, let's see in the Google Cloud Platform how this is, looks like. So this is the welcome dashboard. You can use either here the search in order to look up Cloud Run, or inside the menu to actually get to the Cloud Run page. Even if nothing else is used on the Google Cloud Platform, you are able to see here the demo service, which I put it here. Now, when you are creating a service, you have a bunch of opportunities here, and you can eventually use also the interface, but also you can use cloud build and CI/CD tools automation, like launching the pipeline when there is a push to your repository and automatically ship these changes. Now let's go back to the presentation, and let's see next what's on the take. So as I mentioned in the demo, there are different environments where you can run Cloud Run containers. And I want to mention here that there is the Anthos product line where you are able to actually get your Google Kubernetes engine and for select customers on premise in order to combine these tools. Then there is Cloud Run fully managed. And here you have a bunch of features which I want to cover because they are available also for Anthos as well, but it's easier to show in the managed version what kind of changes you have. Now, just a bit about the pay-per-use model. So Cloud Run has the notion of CPU memory. You are able to choose CPUs for your, for example, complex containers. You are able to choose up to 8 GB of memory, and there is requests. So these components have their own specific price component, and the minimum billing, let's say, segment, it's not 1 second on like on other vendors, it's 100 milliseconds. So you are able to actually fractionize a bit of content, but that's not quite the best thing. I would say a lot of the advantage of this Cloud Run model is that how billing time is being measured. So you have your instance, which eventually, let's say, has a starting point, or let's say a cold start and then a shutdown, and you have 2 requests, and you are not paying separately the billable time for it. You are actually paying the longest time that the active request had in your environment. This is actually good because you are able to measure and you are able to add multiple requests to your containers. And later we will see that we are talking about multiple concurrency, not in the case of functions where you have concurrency only one. Here we have multiple concurrency as well. So if we are able to see that there is the CPU memory and the request components to this service, we see that there is a pricing for CPU memory and request as well. It has a generous plan for first starters who never worked on the Cloud Run environment. And also the pricing is very generous compared to a tool that can automatically scale to, let's say, 300,000 requests and so on. So it's just the starting for this kind of business. Now, to get more practical and to show you some features, let's raise the question, is Cloud Run the king of serverless compute? And let me show you what I consider very important and how it changed for us the container world and running applications inside the Cloud Run environment. So if we are talking about dependencies, because that's in the serverless world a key topic, we are able to observe that legacy function as a service solutions restrict the tools provided. So you can have only certain versions of libraries. You cannot bring your additional, let's say, already pre-trained model or something like that. You can already use what the tools provide you for that. Cloud Run, it brings any dependency and any binary to your application. So it has the amazing flexibility for this side, regardless of language and runtime to your code, which means that you are able to combine a node runtime and, for example, run a useful Golang binary as shown in the note. This is not the only benefit. There is the testing capability. In the serverless world, let's say traditional serverless world, always there is a promise of an emulator which could be somehow compatible, but it may not be compatible, or it could be hard to actually train and run debug operations on that. But Cloud Run concept is containers, and containers make the testing experiment more consistent, because what you run locally, it runs the same way in the cloud as well. You have code and dependencies always patched together, packed together. This is very important. Oh, sorry, somehow jumped. So always you have the dependencies patched together, and that's very important for the debug purposes. So next, what I consider amazing is that it has traffic controls, and that's something that literally changed how we approach serverless, because we had this issue to put something into production, then we wanted to change something there, and there was no maintenance mode. We cannot shift the flow of the traffic or even stream to have a traffic control operation, to have 10% of the traffic to the new version, or have a debug mode like a CI/CD pipeline to have a test mode while it's there. You don't need to run it, for example, on the live instance. You just need to run on a candidate version. Cloud Run resolved this, as you are able to have traffic control for your revisions. And when we are talking about revision, I need to mention that a service has a bunch of revisions, and you are able to tag them, and those labels tags are helping you to actually test different candidates. You can have more than one candidate here. And when you label your services, you actually have access to the gradual rollout strategy. You can find even on GitHub projects that automatically install this extension to your project and automatically monitor the logs. And if there is no exceptions and the metrics are okay, automatically promote a candidate revision to your production revision. So, well, as I mentioned, there is a no traffic option, like in the command line option, which you deploy a service and it stays out of your flow. There you can manually send traffic, or the CI/CD pipeline actually can run the tests on that version. Then you have the candidate and the latest. So it's a perfect tool to actually that results in an automated way to gradually roll out new revisions. And that's one of the features that I really like. The fourth one, just a bit about portability. When you are talking about function as a service platforms, even if we name AWS, GCP, Azure, they are extremely different. You cannot change quickly the compute platform, and you actually have a vendor lock-in. But Cloud Run had resolved this. How? Containers. That's your environment. So one day you start on Cloud Run, next day you can move on premise or even to a different cloud vendor. And you have the ability to deploy anywhere your source, not the function, the entire folder, your source. So results a service that doesn't have a vendor lock-in. Now, practical use cases, because people are actually very interested to see how we are approaching some aspects of running serverless containers in production. So let's talk about cold starts. As I'm showing you in the pain points, you were able to actually see, you were actually to see that most people voted for cold starts, and let's see how it resolves that problem. We can start with something from, let's say, Wikipedia, like use a linear base image, let's say Alpine distro-latch, or if you have a statically linked binary, you can use a Scratch container as well, which is just an orphan container in a sense of word. Then this actually limits the number of, let's say, size of your container. But in Cloud Run, size of the container is not a matter for the cold start. What the operating system runs when the container is initiating is very important. So that's one you to minimize using a right base image. Now, global scope. You may wonder why I'm mentioning here that there is a global variable cache, but all these actually end up to understanding concurrency, which we will discuss in a moment. Here we have multiple requests hitting the same container. They are not totally separate. They are hitting the same container. So if you are able to have on your very first request to the container, which could be a CI/CD pipeline, or just before adding traffic to the revision, you can warm up the cache, set up some global variables. It will reduce the cold start, because that's the first interaction with your container, and it will reduce latency later, because not every request will need to actually work around the global variables and the cache as in the functions environment, because you have heard that functions are separately and they actually don't share anything between us. So this brings us to minimum instances. Cloud Run has the concept of minimum instances, and certain clients have the ability to actually leverage this kind. And we are using as well these minimum instances for some kind of workloads where the front end, the website actually loads in for the user. It's a low traffic website. It doesn't have traffic in the middle of the night, but as soon as the first request comes in, it's there. So minimum instances help us doing this. It has a price, but it's 10 times less than a regular price. And this is very appealing for us. You are able to set multiple minimum instances. And the trick here is that you can automate, like in DevOps style, to set the minimum instances. So for example, if you know that the campaign will start in the next 2 hours, you can activate the minimum instances just before that and keep it like on standby your containers. And when the traffic will hit the container, it will automatically serve all the requests that you were waiting for. So minimum instances can be set also by the CLI, by the UI, and I didn't mention so far, but Cloud Run services are actually described by a YAML syntax, which is very helpful. You are able to see here that it's based on the Knative open source initiative. So all the Cloud Run platform is based on Knative, and you are able to set, for example, the minimum instance here. And the CLI commands are actually great for DevOps to actually serve it. You can use it like for the update, which means that for an existing service, you add or take minimum instances, or you create a new service giving the value for that. Now, auto-scaling. Yeah, this is a debatable topic always, because people tend to have always hidden risks for auto-scaling, which are as well here. So it's not something that should make it away. Like, you need to be aware how the service is constructed and what you are paying for. So when there are no requests, scales down to 0. That's great. It's very cost-saving service. So for example, you can run a personal blog page for costing almost nothing. but it's also great for enterprises where you have certain batches of work that you want only to use in the serverless environment. You don't have the ability to prepare VMs, or the manager didn't allow you to use the VMs and so on. Now, some numbers. By default, each service can scale to 1,000 container instances, and this is available for everyone. But if there is an enterprise who, for example, wants to run a, let's say, Black Friday day, they are able to increase it to the sales rep of the platform that they are on, and they can run more instances for a service. Now, next number is that the instance itself can handle simultaneously 215 requests. And this is very appealing for developers because it opens you a way new world of projects. For example, WebSockets. WebSockets are actually eating a lot of requests and operations for you, but it's very important to resolve this kind of WebSockets in an automatic scale. You don't need to provision a lot of machines for these WebSockets environments. But there are risks ahead, as the science shows it. And if you do a quick math, you are able to see that you are able to run 250,000 simultaneous requests, which cost a lot of money. So if you want to do that, and if you have a service that needs this, you are able to reach easily without any quota upgrades these kind of levels. But watch out if you just start with it, because it can actually cost you a bunch of money if you get an attack. And here we need to talk about concurrency, and concurrency brings me a topic like in the functions world, where you had a fixed concurrency of 1, and it was easily, for example, you didn't had to pay attention for memory leaks, because it came the function, it went away, a new instance was coming up. But Cloudrun enables you to set concurrency. And default, it's 80, which limits the risks that I mentioned earlier, but can be increased up to 250 just by YAML syntax as well. Now, a certain guy have blogged about this, like a free trial experiment ended with a 72,000 bill overnight because he had some errors in the code and he didn't observe it, that he left the code there running and so on. So common errors that people have in the Cloudrun environment and using a lot of requests and so there is the uncontrolled retries loops. So if you don't pay attention, and if you have a, let's say, a failing test, and you don't have the ability to have a backup, you are able to get into a loop that gets you request, and so on. Also, there is unwanted traffic. Suppose that a URL leaks. The concept of leaks is different here, but leaks out, and someone uses that, for example, to burst the traffic on that. You are actually paying for this. So remember the pain points of the serverless world. So they are here, like controlling the billings, but there are options for this, and that's why I'm actually like this service, because it lets you to control. You can set concurrency to low, very low number. Even if someone comes with a large number of traffic, it's being kept low, and you are able to connect additional services, like, for example, identity-aware proxy or endpoint service, where you can have automation for an authorization part for that. And of course, if you want, for example, to avoid the DDoS concept, you are able to use Cloud Armor or load balancer with WAF and all kind of rules. Let's see also benefit of concurrency and how affects billing for that. And I want to mention you, while looking at these charts, that you can ask questions, and I can answer that at the end of the sessions. So concurrency, we have here the same number of clients, like 400 clients making simultaneous three requests in different scenarios. Here we have concurrency 1. We had needed 520 instances, and if we have concurrency 80, it needed a lower number of instances. Why is good to have a lower number of instances? Because you need to pay the CPU and the memory for that. So just by working on the concurrency, you are able to actually minimize the number of instances that your service runs. Also, I want to mention that you need to keep inside the memory of your container. That's maximum 8 gigabytes, but usually people run 256 megabytes small instances. And even if you, for example, accept, let's say 80 concurrency for that little instance, maybe 80 requests the container with 200 megabytes it's not serving, but maybe. So I would say here that, let's say a WordPress PHP application compared to a Node.js or a Go runtime behaves differently. While a WordPress needs a bunch of memory to run, but you can run it as well, a Go could serve easily 250 concurrency as well. So it's very, very, very recommended for you to actually set and use the right number of instances for your study. Okay, load balancer. So this is just a quick example that you are able to have in the beginning. So before the Cloud Run service, you can have a serverless point. And here you have an optional URL mask, a map, and eventually HTTPS, let's say, custom certificate and a forwarding rule as well. But actually, I wanted to get to this chart. And this chart shows you that you can have services in multi-region. The same code, you can deploy the same code to, let's say, Europe and US East. You get, let's say, 2 separate services with different latencies for your users. And in order to leverage this kind of latency, you are able to add a load balancer. And in the load balancer, you name the same service for that. And the load balancer automatically, out of the box, takes care for you that a user in Oslo gets the European version and someone in New York gets the New York version as well. So you save some time, for example, intercontinental billing, and also the latency benefits that the user gets. Now, let's run another demo. And the demo here will be WebSockets, because Cloud Run offers WebSockets and HTTP2 as well. And those kind of features are for advanced users. We are going to use something extremely simple. We are going to clone a socket.io Git repository. There is an example for a whiteboard. And these 3 commands is the one that we actually need to run it. So let's try to do that. So actually socket.io, I think it's already on my, yes, it's here. So let's clear what's in here. And let's change to that example cd. Okay, I am on the right folder now. And I need to run a command to actually get this service up. It asks me to run on fully managed. I choose US Central, and I want to be available for the public. Of course, you are able to add these on the command line as arguments. It's not always asked for you. What it does is that you have the socket.io and you have the example of the whiteboard. In the whiteboard, I need to say that there is no Docker file. And this is a hidden feature of the Cloud Run because it has the build packs support. So automatically, based on build packs, figures out what kind of containers you need for your service. It's extremely helpful to get started for folks that are not have the ability to actually use and build out containers. The service, if you want to check at the URL, let me show you, because last time didn't show you that. So we are here, and comes in. So here is the bootstrap, and this is a different product. It's called Cloud Build. It's actually hidden inside the build process. So you may wonder when the container was built, but Cloud Build is the one that actually builds the container. It already finished. So now we are giving permission because I opted for the public availability, and it creates revision, routing traffic, and it's done. There is a URL. Let me click it. Okay, this is the URL. And this is actually, I need to open it in another browser as well. So I'm choosing another browser. And in order to show you that this is actually working in, let's say, WebSocket environment, I'm using two browsers, and we can, for example, use here all kind of options. Developers, whatever. I'm not the best with mouse to actually read. So if you have the ability to use WebSocket, yes, you have. People have asked me that, oh, okay, great. This is great for serverless, but where is actually the concept for this? Well, there are advanced options like WebSockets and HTTP to actually run this. Okay, while we are here, let me show you another example, because I mentioned Cloud Build, and Cloud Build is something that people ask me how they run their own Cloud Build pipeline. So we are going to another folder. I prepared here Cloud Build. This folder actually has a simple HTML file as the content, but it has a Docker file. It doesn't matter exactly what a Docker file is. Also, we have the Cloud Build steps. And here you are able to see that, for example, this is the Docker container that is the Docker that is actually runs the build command. Then there is another step, the push, which actually makes to push my repository to my repository. This is where my build container will be. And then there is the gcloud container, which executes the deploy command for building the Cloud Build service. Now, this is a YAML file. In order to run the YAML file, you actually need to have a different command, Cloud Build, and gcloud builds submit. So that's the command gcloud build submit. So this is actually, we run 3 steps, and that's what already happened with the deploy command. But here I'm actually able to see you by using individual steps. What abilities you have here is that you are able to, for example, add the region, add the platform. You can have here managed or your Kubernetes platform, allow authenticated, and also Mux instances and other parameters as well. While this is deploying, I'm opening a new Cloud Build file. And here I want to highlight some additional options. Like, people ask me, how do you attach a database connection to a serverless environment? Now, you have a command for that. So you are able to add a Cloud SQL instance, and here you have the instance name, which describes the instance of Cloud SQL that you are running, and that actually connects you by Unix sockets. So in your application, if you need to connect to the database, you are using this instance Unix socket actually to connect to the database as well. And here are other examples like how you set environmental variables. You have here instance connection name exposed as a variable, but you could have here as well added additional parameters for your environment, like it's a production environment and so on. So the service is up. You can see here all the layers. Here is the URL of the service. You see here that it's HTTP based. It has a random URL, but Cloudrun supports custom URLs as well. You were able to actually notice that on the screen, but you can map also in the command line. You will see here all the buzzword and manage custom domains. Here you have the opportunity to add the mapping of the service that you want to map for. You add the DNS records, and for you it's there. Now, as I'm approaching the end of my sessions, so let's see conclusions. You have a simple UI and command line options to quickly deploy and manage services. It integrates with Cloud Code. Cloud Code is an extension for the IDEs that you use, VS Code, for example, in order to run certain automation operations for Kubernetes as well, but also for Cloudrun as well. It integrates with Cloud Build, and it's ready for continuous deployments. It's auto-scaling out of the box, scales down to 0, but it scales to super large numbers. It has built-in redundancy and replicated multiple zones. You just need to grab the container and put it in a different region, set up a balancer before. It out of the box offers HTTPS URLs, endpoint, and custom domains. It enables invocation by HTTP2. You need to enable that option inside the YAML file, or on the command line, there is a specific command for that. WebSockets out of the box, and gRPC as well. So those folks who love the APIs that are based on gRPC and not the old-fashioned REST are able to run their workloads on Google Cloud Run nowadays. So actually this concludes all my talk, and the rise of containers and the rise of serverless in the latest years, and the newest features that people can leverage on this tool. So let's see what kind of questions we have here.
Okay, hi Marton, can you hear me?
Yeah.
Okay, perfect. Thanks for the presentation. I think the audience has enjoyed it. First question from my side, did you enjoy it?
So I enjoy it. It's really hot because I have here a light and I got this fleece of it. So for me, it was like a hot, but hopefully for the audience as well, it was a hot topic and they can use this information at their regular days.
Okay, perfect. I see we have 2 questions in our Q&A tool, and we also have some comments on YouTube. So let us just get the questions on the screen. Just a second. Okay, so first question. What can you say about migration to Cloud Run from other platforms? I think we are missing here a bit of a context, but maybe you can give an answer.
Yeah, that's actually a great question. Hold on. Yeah, that's actually a great question, because a lot of people are not starting running production workloads right now. They want to migrate. As it's a container experience, you are able to package the code and to move into this environment whenever you want. The biggest question is that what kind of dependencies you have. And I'm not referring to the code dependencies. I'm referring to, let's say, infrastructure dependencies. If you have a database, you need to migrate the database as well. If you have a storage system, you need to make sure that there is there is a connection possible for that API and so on. Also, Cloud Run is stateless HTTP, so it means that the disk is not persistent. The disk is there, but it's not persistent. So you need to actually enable some shipping of your disk contents, like files, logs, and so on. But here comes, for example, the automatic log service comes very helpful, because whatever logs you have in var logs, we are talking about Linux containers here, whatever you have under var logs automatically are exposed as a log service to Stackdriver or some other services. So it's actually great. And one more point here, a lot of people have migrated old version code, because in the environments you currently run, maybe you get out of support of a legacy version, but in Cloud Run you are able to run even, let's say, Pascal, COBOL, whatever container you build out, or some old version of, I don't know, WordPress or whatever there is in order to run it. And that's very easy to actually run it in an old version. I highly recommend against, because you need to be up to date with nowadays security implications, but it's an option for a migration period where you update your code.
Okay, perfect. Sounds very promising. Next question is, why are people often complaining about WebSockets and Docker? And what are the real cons?
So they forget that WebSockets is a TCP thing. And when we are talking about a container, that's an OS. And the OS needs to be tuned, because default, they cannot handle all kind of, let's say, harsh usage of WebSockets. So first of all, you need to tune your TCP socket layer and build your container with that in mind, and then you will have no problem with WebSockets. And in case there is a problem, remember that there is a limitation of resources, like number of files open or number of leaves open in the Linux containers. Those need to be raised, or it needs to have multiple instances of the Docker container. And I would say not Docker, or container. So it's totally different business. I'm running WebSockets up to 100. So that's how we actually set up. But we have a lot of small containers, like 128 megabytes of container. And we have a bunch of these in order to support all kind of latencies and the limitations of the TCP layer.
Okay, thanks for the answer. Then we have one comment on YouTube from Damian. He's saying, in his opinion, Alpine-based images are not the best. He has some experience with Alpine, lack of glibc and so on. And the next con is security, because some scanners don't find any vulnerabilities in Alpine. What's your take on that?
So we are using for some projects, but there, let's say that I agree with some kind of workloads have a sensitive to some kind of environment. But the nice of containers is that if you find out another better, let's say, setup, I wouldn't say distro of that, a setup, you can vouch, you can blog about it. That would be a very, very useful topic. Even if you run into a side effect of it, you can see that you can document like, hey, this is running like this, it's bad. And I tried out a new environment, and there it compares and it's different. And for example, in Cloud Run, I've seen similar topics being on the internet. For example, people benchmarking different runtimes, different distros, because on Cloud Run, you can have the same application on different distro as well. And you are able to see in production how it behaves. And where there are, let's say, security scannings, because if you have a container, you should not forget about your container. You should constantly scan for vulnerabilities, or have a team that actually checks what updates you can have, because people tend to forget. They build a container and it lasts for 2 years. That's bad. You need to actually run a tool on it. You need to constantly update it, and you can do that part of a pipeline. And for example, only for this kind of business you can use Cloud Run, because it will be a second service, just this workflow check.
Okay, perfect. Thank you, Martin. We are already tight on time, so I just want to say quickly again, thank you very much for joining us, and I hope that you will be available in the future as well for our upcoming events. Have a nice day, and see you next time.
Yeah, thank you for having here, and you can find this presentation on SlideShare later, and connect me on Twitter, LinkedIn, whatever, where you want. See you next time. Hopefully
Bye-bye.
you have a great day. Bye.
Thanks. Okay, we are moving on with our programs. So in a couple of minutes we will have the next talk. It will be from Adrian, and it will be about reusing apps between teams through containers. So stay tuned. We will be back in a couple of minutes. Take the time to grab a cup of coffee. Welcome back, everyone. So I have here Adrian with me. Welcome, Adrian. How are you?
Very good. Thank you so much. How are you?
Good as well. So where are you joining us from?
Zurich.
Zurich.
Rainy Zurich today. Yes, very rainy.
That's nice. That's nice. Yeah. Adrian, what will we learn from you today?
So today we are going to see, we're going to go beyond the use case of encapsulating cloud native apps inside of a container. And we're going to see different ways to use containers to share tools with your team, internal tools with your team, and also how to use them in CI/CD pipelines, which are so important these days.
Okay, that sounds very interesting. So looking forward to that. Adrian, the stage is yours, so I will get out of the way. See you later.
See you later. Thanks, everyone. Thanks for the invitation. We are developers. Thanks, everyone who's joining from all over the world. My name is Adrian Kosmaczewski. I'm developer relations at Vision, and today we are going to see different ways to use containers to help your team do more and better and collaborate better and reuse these tools that you build internally all the time. And we're going to see some of the challenges, and I'm going to give you some tips and tricks to build better tools. Before I start, I would like to say a few words about my company, Vision. It's basically pronounced like the word Vision, hence the I in the logo. We are in Zurich since 2014, and we are the experts in everything that has to do with Kubernetes, DevOps, OpenShift, and 24/7 support for companies, particularly in the DACH region. We have a few certifications as well, but most importantly, we've been the first company to be certified Kubernetes in Switzerland. You can follow us online on Twitter with the Vision_CH user, and on YouTube as well in vision.tv. We are partners with several companies. You can see the logos here on the slides. And we love containers so much that we actually host our own container platform so that clients in Switzerland and all over Europe can have their containers safely stored and running inside of Switzerland. So this is Apuyo. This is one of our products, and Project Sin is another product we are developing that allows us to manage 1,000 Kubernetes clusters from one central point. A very interesting open source project that I invite you to discover. But enough about Vision. Let us talk about the subject of the day. And basically what we've seen in Vision in the past few years, when companies get to use containers, they basically first approach those containers as lightweight virtual machines, right? This is the first thing that everybody does with containers the first time you play with Docker, and companies do that as well. Then they move on and they discover that they can compose many of those lightweight machines together and set up the networking and have more complex setups using Docker Compose. And then at some point, they move to Kubernetes. But I'm not here to talk about that precisely today. We're going to go beyond the usual use of containers, which is exactly what you just saw, Docker Compose and Kubernetes. We're going to learn how to use containers to do much bigger things and very interesting things as well. So the agenda for today is very simple. We're going to see a little bit the challenge of internal tooling. I hope I'm going to mention some pain points that you might be feeling. And the good thing is that you are going to feel together with many other companies all over the world feeling the same pain. So you're not alone. We're going to see how to encapsulate and share those tools and how to reuse them in CI/CD pipelines as well. We are going to see container ideas, stuff that you can use these containers to help you and your team do more and do better. And then I'm going to mention some gotchas, some basically tips and tricks of things that we've learned internally at Vision that basically have made us build better containers and work better with them. So first of all, let's talk about the challenge of internal tools. So in the redtool.com website came out a couple of weeks ago, a very interesting state of internal tools in 2020. We all have in our companies internal tooling, applications, Excel spreadsheets, dashboards, stuff that we create for internal use, and that is software. We create software. All companies are software companies these days, and this internal tooling becomes very important, like critically important. And if you look at the answers for most of the respondents to this survey, the answer is overwhelmingly positive in the sense of the criticality of these tools. However, it is also very, very sad to see that these same companies, these same enterprises, usually cannot allocate enough time and money to the betterment of these tools, to solve bugs, to release new versions, to keep them updated with the environment, and so on. In Vision, we've got lots of internal tools. Our job is to manage systems for other customers, 24/7 management. So we have plenty of tools that we've created internally. And that blue text on the slide is actually clickable. You're going to have a copy of the slides as well, able to download. You can see the names. We actually have published all the names of our internal tooling in our handbook. Not only that, but we have taken the decision in Vision to allow each and every Visioneer, that's the name we give ourselves in Vision, to use whichever operating system they would like to use. So the overwhelming majority use Linux in various flavors, typically Ubuntu, Arch, Fedora, and others. But there's also people using Macintosh and Windows even. So we have to find a way to distribute this tooling all over the place. So for us, it was a challenge. And then there's the programming language challenge. We build tools using the best programming language, and the best programming language, of course, depends on the context. Every project is different, so depending on what we want to do or the libraries we want to reuse, we're going to choose this programming language or the other. Regarding programming languages, this is a very simple point that I would like to make, and I think it's quite obvious. You can divide, when you build tooling with containers, there's basically two families. On one side, you've got Go, Rust, C, and C++. They are usually great for cross-platform CLI tools. They create very tight code, very fast, very efficient. But they can be a little bit complicated to build. You need Ninja Build or CMake and several tooling going around, and maybe a little bit of Python to put all together to generate make files to make your application. On the other side, we've got programming languages like Ruby, Python, or JavaScript. They are very agile. They are great for prototyping new apps. You can get your code out and running, but they usually require very big libraries and runtimes, and you've got to somehow help your teammates to get the proper version of Node.js, the proper gems in Ruby, or the proper eggs for Python, and it becomes kind of a very complicated issue to manage. So we've got a trade-off here. We have to find a way to distribute our applications no matter which situation we are. And it turns out that containers are great for encapsulation and sharing. I am going to take you through a very simple example. We're going to be using Podman. I don't want to use the official Docker tools. I'm going to use Podman in this example. I'm going to use Red Hat Quay, of course, as well as an alternative to Docker Hub. I want you as well to open up to other alternatives. The world of containers is really interesting these days. And for showing how to encapsulate and share a tool, we're going to use a very simple tool called Greeter. So Greeter is a TypeScript application. It's an actual app. You can download it from GitLab. I'm going to give the URL right now in a minute. So if you want to follow live, you can connect directly to GitLab and see the code. And when you use TypeScript, actually, that usually defines that at some point you're going to be NPM downloading the internet. You know that 15 years ago, Maven was downloading the internet. Right now, the crown goes to NPM. So every time you want to build an application written in JavaScript, you're going to be downloading a myriad of libraries. The ecosystem is very, very rich, but at the same time, very heavy. And here is where the application is located. You can go to gitlab.com/acosma/greeter. That's my personal account on gitlab.com. You can see the code of this application if you'd like. What does greeter do? Very simple. Just what you see on the screen right now. It greets you. It's just a very nice character that will say hello and put whatever text you put at the end. It's a very simple thing, very simple application. And I'm going to show you how it works. So I'm going to click on this play button. And here I have a recording of a shell session. So I have cloned my project. I have my package.json file that defines my Node.js application. If I look inside, I see a few npm scripts like build, release, clean, test, the usual stuff you would say for a JavaScript application. I've got a few dev dependencies, for example, Chai and Mocha for testing, and of course, TypeScript related tools like tsnode, tsmocha, and typedoc. Finally, I have runtime dependencies, the most important of which is Commander. Commander allows me to parse arguments and parameters on the command line very easily. So I just type npm install and we download the internet. In this case, it's not very long. It's actually quite fast. It was cached. And now I have a Node modules folder in my project ready to be used. I can run a couple of tasks, like, for example, npm run build. This will use the TypeScript compiler to generate an out folder that you can see below the Node modules folder here. So now I can node out source index.js. And if I click enter, by default, the tool will output the help text because I have to pass a parameter. So how about passing WeAreDevelopers? So I pass the parameter WeAreDevelopers, and here we have our cow outputting exactly what we wanted. I can change the character as well. I'm not tied to always having a cow. I can use a bunny, a very nice bunny that appears on your command line. And not only that, I can see, of course, the help, and I can see all the different characters that are available. I have even the Mona Lisa, if you want. So here in this case, what I'm going to do is to change the action, and instead of talking, I'm going to make the cow think. And the only thing that changes is basically the little bubbles of thought going out of the head of this poor cow. Very good. These can be encapsulated inside of a Docker container. And for that, one of the best, and I stress this fact, one of the most useful things you have to learn regarding the creation of command line tools inside of your containers is multi-step builds. It is a very interesting technique that consists in using temporary images that you're only going to use for build time so that you can install all of the tooling that you need, compilers, linters, anything that you need for your application. And then you're going to use a secondary Docker image for runtime only. So in this example on the screen, as you can see, I'm using the Node official Node Alpine image for version 14.15 as a builder. And there I can npm install the whole world. It's okay. Then I can build my app. I can run release. The release task on npm, basically what it does is to create an optimized, minified version of the JavaScript at the end. This is the only difference. And then I have a runtime image, which is Alpine. And Alpine is a great choice for runtime images because it's very lightweight. It doesn't include much. Actually, it's very, very bare bones. However, the type of build that I'm doing, I'm creating using a project called PKG. I'm going to mention that again. I'm going to link to it as well in a few minutes. It creates a standalone binary with the JavaScript code and all of its dependencies ready to be deployed. And I call this greeter.bin, as you can see on the slide. And then I set the entry point to be that greeter application in user local bin. Very good. So this is very simple. Let's see what happens when I build my container image using Podman. So the which Podman command I included here just to show that I'm not aliasing Podman to Docker. I'm actually using Podman here. And I would like to use Quay to share my image. So I have to log into Quay and I can use my username and password for that. There we go. I'm logged in. I'm ready to share my images. The first thing I need to do, of course, is to build it. So Podman build using the tag quay.io/acosmas/greeter:1.0. And of course, this builds. This is not very different from the usual Docker build command that you have typed before. You have typed before so many times, I hope. In this case, I'm also running npm test. So I'm running the tests during the build process. So basically, you don't want to create an image where the tests are not passing. So here, of course, I only have one test. You could have more. But if the test step returns a value other than 0, then the build process stops. And you can actually be notified of that. Here we are right now installing only the production libraries. You might have seen npm install -- production going on. This is a very interesting technique in npm. It only installs the libraries that are used at runtime, not at build time. Now I'm using pkg to generate my self-contained binary that contains all of its dependencies. And now I'm finishing the process. After 21 steps, I have my final image ready to be shared. What I do right now is I can see it locally. I basically have to push it. Podman push quay.io/acosma/greeter:1.0, and up it goes. This is in real time, by the way. There we go. That's it. Very simple. Nothing very different from what you've seen so far. But then again, I prefer to repeat. Of course, Podman build, then Podman images, Podman login to Quay, Podman push, and actually you can go and check out on quay.io/repository/acosma/greeter. You are going to see the repository that contains that image that has just been uploaded. Well, here's a little secret. It's been there for a couple of hours, but you didn't know. It's okay. So now we have our image in quay.io. Well, let's reuse it. And what better place to reuse stuff created by your team than in Windows? So here I have a small video, very simple, where I'm using the new Windows terminal made by Microsoft, and I have Docker Docker desktop installed. So as you can see, there are no images and no containers running. This thing is empty. It's virgin. It's ready to be used. So this is great. I can check now that I don't have node. There's no node in my command line here in Windows, but I do have Docker. And this is great because then I can use the famous Docker run command, which is what I'm going to start typing right now, using the --rm parameter, which I will explain in a minute what it is for. And it then references exactly the same tag and version of the image that I just created. And I pass my parameters because now I know how it works. So I can pass a parameter and I can change my character. And since I like Star Wars so much, I basically will make R2D2 talk and say hello from Windows. So of course, the image is not here. Docker has to first pull it, bring it locally, set up everything so that it's cached and stored for reuse afterwards. There we go. Pulling, extracting, and executed. And now we have a very beautiful version of R2D2 on ASCII art telling us hello from Windows. Of course, we can continue. For example, I could change the character. I could make a cat thing. So here I'm going to change character to cat. And boom, we've got our cat greeting us from Windows, but thinking about the greeting because cats are mysterious like that, you know. If I look on Docker Desktop, I see that I have my image ready to be reused. And if I go to my containers, I see that the no containers are running. And because I use the --rm parameter in the Docker run command, the container is basically deleted after it finishes its execution. So for command line apps, it can be interesting to use this parameter because otherwise you will end up with a lot of zombie containers that are half dead, half alive. No, they are dead actually, but they will be taking space and so on. So you might not want to keep that in this case. So it's a useful parameter to use. Very good. Let's move on. How do you reuse this tool in other contexts? Because here we've seen that we can reuse a container created with Podman on Linux. We've reused it with Docker desktop, on Windows. So it's a very interesting thing. We've got standards here at play, right? These two tools are actually collaborating and playing along quite nicely, which is great. Let's see how GitLab plays along as well. One thing that I have to add for any project in GitLab to start working in my favor using CI/CD is the .gitlab CI YML file. This is the standard file that defines a GitLab CI/CD pipeline. And I have one. You can actually check it out on the project, on the Greeter project. It's a very simple one, but it does something very interesting, is that it uses the Dockerfile of the project, and it basically logs in to CI registry, CI_registry. I don't know if you can see this variable right here. I suppose you can see it. And those variables that you see on this command are automatically populated by GitLab, and they point to the GitLab, to the container repository embedded inside of GitLab. So GitLab actually can be used as a replacement for Quay, and that is fantastic. And we're going to do that. So our script is very simple: Docker login, Docker build, and Docker push. That's basically what we do. We run the pipeline. As soon as you push your file, you commit in Git and you push it to GitLab, at that moment, GitLab starts executing your pipeline. Actually, it might take a few minutes until there's a worker available for you, because of course here I'm using the free version, but that's why I basically only put the final screenshot in order to avoid waiting. And here you can see a Docker push, a green command in the middle that says Docker push to the CI registry /acosma/greeter latest. And the job has succeeded. Now, where is our container? Well, we can go to the packages and registry and to the container registry of our GitLab project. And this, again, is something that you can see live on the Greeter project right now. And it contains a container registry. And that container registry contains the freshly built image that we were looking for. And it is so cool that you can actually Docker login and Podman login on that registry and use that in your own workflows for your own personal use. So this is an interesting thing that you might consider as well as an interesting bonus for using GitLab. Now, let us reuse that in the GitLab CI/CD pipeline of a different project. And I have a separate project, always in GitLab, called GitLab Acosma Fortune. It's a small application written in Python, so it has nothing to do with JavaScript, thankfully. So basically, we are going to reuse a JavaScript tool into the CI/CD pipeline of a Python application. And basically, the only thing we need to do is to use the multi-step build that we've seen already at play in the previous project. We're going to use it on this new project. And here, it's a very simple thing I'm going to do. It's basically, I'm going to print a greeting. So in the Docker file, I'm going to reference my freshly built registry gitlab.com Acosma greeter image. And there, I will run my greeter program with the word Dockerfile as a parameter. And I want Snoopy to think about it. That's exactly what I want. And then the rest is the standard Python build application. So as you can see, it's a web application exposed through port 9090. You can actually check it out if you want. It's a very nice small application that we use for demo purposes at Vision. And it basically returns the cookie, the fortune cookie of the day. You know, some phrase that you might read in a restaurant where you open the fortune cookies and you read some fortune message for you and your future. Then we need to, of course, have a GitLab CI YML for this second project. This is the GitLab CI YML for Fortune. It defines what's going to happen. So in this case, the only thing I want to do is simply Docker build, Docker push, Docker login, Docker build, Docker push. It's simply built in a separate way. It's simply written differently, but it's basically the same GitLab CI as previously. And when you run it, that's what you get. You get Snoopy thinking about hello Dockerfile. That's exactly what we wanted. And now we can reuse that image in all of our projects very simply just by referencing the tag and the version of that Docker image. But of course, I suppose that this Docker image will not be very useful. I don't see anyone watching this video saying, running to their boss and saying, we could have Snoopy in our CI/CD pipeline. I don't expect that to happen. This was just an example, a very simple, very graphical example of how you can tie all of these components together. We're going to see now actual ideas, and these have been implemented inside of Vision. And many of these are available as open source projects on GitHub. So that means that you could be checking them out as we speak, and maybe, who knows, maybe reusing it. And of course, they are open source projects, and we are very happy to receive your pull requests if you would like to have, if you have an idea for an improvement that would benefit the whole community. So let us talk about two kinds of different ideas of things we could do with these containers. First of all, there's code tasks. So what could you do with code? Well, code is a very complicated thing, and it gets more and more complicated as soon as more people put their hands on it. And basically, sometimes you want to separate the infrastructure from the code itself. It's actually sometimes a very good idea, particularly for very big projects. And we've actually implemented linting of code as a separate component. This is something we can do. This is something that you can reuse then in other projects with similar characteristics, typically similar programming languages. The same you could think of the same for black box testing. We're actually thinking about starting to use K3D or Kind, which are Docker compatible Kubernetes distributions that allow you to run a small Kubernetes cluster inside of Docker and to run a battery of black box testing on top of that. Why not? It's totally possible. It runs on Docker, and maybe we can have some automation on top of that, just to make sure that everything that you deploy on your actual deployment clusters, it's not breaking. And then, of course, API documentation generation. That's a canonical example, and it can be very useful to have, for example, your documentation generator, including the styles, the CSS, the fonts, everything that has to do with your own identity or your own corporate identity on a separate component that can be reused by all the team. This is something that is also very useful. Speaking about documentation, this is the second kind, and it's one that basically we have worked a lot. We do a lot of documentation for our customers. We are certified ISO 27001, so we have to document a lot of what we do. So we work a lot with documentation tools. And look at some of the things we are actually doing with containers in our CI/CD pipelines. We find dead links in HTML. We basically run this tool on top of our whole auto-generated websites with documentation to see if all the links are working. How about that? We can check the writing style to make sure that everybody writes more or less in a similar style. We have an automated style checker for our tool that is also running on CI/CD. And of course, we have a spell checker, because you also want to make sure that everybody is spelling correctly, particularly because, well, we are not native English speakers. You can tell by my accent that I'm not a native English speaker. So clearly, we need some help in that respect. We can also use separate containers to generate PDF and EPUB. Imagine that we have containers images that are publicly available, and the links are on the PDF that you're going to get, that can be used to generate a PDF fully branded, ready to be read, and nobody has to install a single Ruby gem. So yes, it uses Ruby, and there's a lot of gems to install around this pipeline. So here we have one container that contains the whole knowledge and the whole thing and all the resources required to get a beautiful PDF at the end in one command. So that is a really, really interesting thing. We can generate the search engine index for our documentation. If you go to any of the, for example, our knowledge base or handbook, you're going to see that we have a very uniform search engine, and that is also generated with separate command on a separate container. And then as well, we have live preview for documentation. So when teams are writing documentation, they can have a browser window open where their changes appear in real time on their browser. And that tool is a container as well. And it's also open source. All of this looks very nice, but I wanted as well to finish my talk giving you some warnings, because there's no how do they say, no silver bullet, said Frederick Brooks. So clearly there are some things to pay attention to, and I've classified, I have quite a list. Actually, it's a very long list. I've chosen the most important ones, and we're going to write a blog post highlighting more of them and providing more information on the Vision blog. But for the moment, I want to focus on 3 types of gotchas, which is gotchas creating the CLI tools themselves before you put them inside of a container, then building the container that comes on top of it, and finally, some specific programming language tips and tricks that can be useful to you when you are going to put those code snippets inside of a container. First of all, if you are going to create command line tools, please follow the command line interface guidelines in clig.dev, clig.dev. Fantastic website that provides basically a book with plenty of information about all of the things that you have to take care of, like redirecting std out, stdr, how to handle parameters, how to handle arguments, all of that. Very interesting. If your tool is complex, and at some point in time it will become more complex than you expected, think about creating man page. Man page is overrated, and people think that it would be super complicated because you have to learn trof, rof, grof, or whatever. No, you don't need to do that. There's ASCII Doctor, and ASCII Doctor, we use a lot of ASCII Doctor in Vision, and ASCII Doctor, one of the backends is man pages, and we actually create man pages for some of our tooling. If you need to pass secrets to your tools, which at some point you might have to, one good suggestion is to pass them as environment variables. That is, you make your tool listen and watch and read from environment variables, and then you pass those variables. You can tell Docker and Podman, you can tell Podman to basically run the container using a separate file with all the secrets. And of course, don't commit that file to Git, right? Just remember to never commit secrets in Git. Whatever you do, please document a lot, as much as you can. There's never enough documentation, but the best kind, in my opinion, for tooling is samples, examples, how to use the app, how to, make a greeting with R2D2. Put the examples, write them down. Be redundant. Redundancy is a good way to learn. And one specific trick that I want to highlight is using makefiles to standardize your projects. For example, we've mentioned previously that we are using at Vision Docker containers for checking the spelling of our documentation, for example. Well, actually, people don't have to run Docker run --rm volume and all the thing, because you become crazy. You don't want to do that. So we add a makefile to each one of our projects where we create a task called spell. So here you have the task called spell, and this task will execute the handspell command. The handspell command is defined here, and this interesting syntax excuse me, this interesting syntax on the makefile allows you to override those values when you call the make command. So that you, instead of using Podman, you might decide that you want to use Docker instead. So it's very simple to just do Docker command equal Docker make, and that's it. Or in this case, make spell. And that make spell will wrap the command that is required to run that tool in your environment. And that could happen. That could be not only in your own machine, but on the CI/CD pipeline that we were talking about a few minutes ago. I wanted to show a live preview. I don't know if we have time. I will leave this for the end. I want to concentrate on the actual points. If we have time at the end, I can show you something really cool using containers, but I will leave that to the end. The second kind of gotchas is when building containers. And this is something that can be a little bit tricky sometimes to understand why your image is built, but it's not working properly. So first of all, pay attention to the fact that some base images, most notably Alpine, uses a different implementation of the C standard library. So this is something that can catch you off guard. It has caught me off guard, of course, and this is how you learn. So basically, pay attention to this. Some tools and some programming languages will build their tools assuming that glibc is available. If you're using Alpine, there's no glibc. You're using Musel, so you've been warned. Every so often, remember to Podman image prune. Podman image prune or Docker image prune. That can save quite a few gigabytes of space in your disk every so often. So I recommend that if you are building container images very often, that you do it at least once a week. Seriously, you'll be surprised about the amount of space these things can take. Prefer entry point to command. You can use them both. But in general, I prefer to go directly with an entry point that it's very clear. You can use command together with entry point to provide default parameters that can be overridden on the command line. And you can actually override entry point as well using the -- entry point argument when you Docker run, or Podman run. So this allows for a lot of flexibility. Also, in general, prefer copy to add. It's actually part of the best practices of Docker. It's specified in their documentation. Add is a little bit of magic bundled around copy. So basically, for example, you can pass a URL and add will download whatever is on the other side of the network and zip files for you and stuff like that. You don't want to do that. Usually, you want to have control of what's going on inside of your containers. So seriously, just copy. And use other container registries, because the world of container registries is vast. There's a lot of options around. I'm going to give some names afterwards. And very important, you might want to inspect your images using Dive. Dive is a little tool. It's a little tool written in Go that I'm going to very quickly show, because this is not a long demo. I suppose you can see this because I'm sharing my whole desktop, and what you see right here is Dive. So you call the Dive command using the name of the image that you want to inspect. And what it does is to show you the layers, those layers that are created when you are building your Docker image. And you can see at all times, in color, you're going to see highlighted the changes that have happened in that particular layer. See, these are the ones they are updated. For example, here I've added in Alpine the lib standard C++ library, and you can see that it's modified several directories like etc, lib, user, and so on. In the third step, when I copy the binary of my app, at that point in time, I'm just modifying user local bin. This is a lifesaver. If you have to build any kind of images, container images, you are going to find this super useful to understand exactly why can't you run this app, where is the binary located inside of the file system of the image, and so on. This is something that is very, very useful. So I really recommend you to check it out. In terms, well, so this was the demo of using Dive to explore images. The links are on the PDF, so don't worry about that. You're going to get that information. In terms of container registries, there's a lot of choice. You can have your own self-hosted container registry. You can run Kraken, Harbor, Sonatype Nexus. You can use software as a service. Like, for example, if you want to pay Docker Hub, it's a very valid option. You can pay Docker Hub, and you don't get any limitations whatsoever. But there's plenty other, like Why, which we've seen in this presentation, GitHub Packages, Container, the Google Container Registry, AWS has its own as well. And if you happen to use OpenShift or GitLab, you actually already have a container registry that you can use. So this is another option. I know many people are using GitLab internally, so you might not know that you actually have a container registry ready to be used out of the box on your installation. Well, if it's been enabled, of course. Let's finish this with some very short language-specific tips, very quick. First of all, for Python. For Python, I cannot recommend that enough the use of virtual environments. Super useful, and it basically brings a lot of sanity with your colleagues as well. For those who contribute to the code, it makes very clear what are the required libraries and so on. So please use virtual environments. They are absolutely superb. And of course, you can then in the Dockerfile specify that you are installing from that requirements text file. If you use Go in general generates absolutely fantastically small and fast binaries, so that's great. So then you can go one step further, and this is an idea from my friend Christian Kremer, who collaborated with me during the talk, during the preparation of the talk, of using the distroless base image from Google, and that will even squeeze more megabytes that you would have thought out of your final image. And it's an excellent option for Go applications. Go applications usually are ready to be used, are completely standalone in general. Of course, exceptions apply, but in most cases are completely standalone. And they are a great choice for this kind of tooling. For JavaScript, I can recommend you to use TypeScript. Don't write JavaScript by yourself. Use TypeScript. And remember the npm install production flag. So for the production version of your images, do not install libraries that you don't need at runtime. You don't need TypeScript at runtime. TypeScript is a compiler. It's a dev dependency. Pay attention to that. For the deployment, you can use package, PKG, which is the one we've seen in this presentation, or you can use Scratch Node. Scratch Node is a series of node images made by an employee from Red Hat that are super small. They are minimalistic. They only contain exactly what is needed for a node application to run. And they generate relatively very small images compared to the standard node images. So I can recommend them. They work very well, and they've been updated until very recently. They continue to be updated. They are very good quality. I think it's a very good idea. Finally, if you use shell scripts, which at some point everybody does, use shell check, please. Whatever you do, use shell check and use the Visual Studio extension for shell check that will automatically highlight all of the little errors and things that could go wrong in your shell scripts. Please, 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 shell check. And second, and very important, not all base images contain bash. And this is the #1 gotcha for Docker container builders like me, is that all of a sudden you've written your script and you've expected bash to be present, and it is not. So remember, many images, particularly Alpine, are based on top of BusyBox, and BusyBox does not contain bash. It contains the standard shell. So make sure that your scripts run on the standard shell, and shell check can help you doing that, okay? Summary, because there's a lot of information here. Do wrap command line tools in containers. It's a great way to distribute code to your peers. Use public or private registries. Doesn't matter. There's plenty of options. You don't have the excuse of just using Docker Hub. You don't need to go only on Docker Hub. Document everything that you can. Please have a README with examples, a man page, an Antora website with documentation and so on. Beware of common issues that I've highlighted in this talk. There's a lot of things that can go wrong, but it's stuff that after a while you get used to it, and then you become very productive. Very good. I wanted to acknowledge and to thank my colleagues Christian Kremer, Tobias Werner, and Arno Aukia, who, at least Arno, I think, is watching this presentation. You gotta follow them as well on Twitter. They are super interesting. We are crazy about containers. And I was super happy to show you what we're doing internally at Vision with containers. And I hope you will start building your own images and sharing them with your team. I think it's an incredibly productive medium, very flexible. And once you know a few gotchas here and there, you can be very productive and make your team very happy. So thanks a lot for watching. It's been great to be here. So if you have any questions, please feel free to, I don't know, maybe write them. I suppose that you can write them also. Thank you.
Okay. Thank you very much, Adrian. It was really a good presentation. I see that you have really enjoyed it, and I'm sure the audience has enjoyed it as well. Yes, you can ask your questions in our Q&A tool, Slido. It's right beside the stream, or you can also write comments on YouTube. I will check that as well. So, Adrian, thank you very much. We have 2 questions so far, so I will start with the second on the screen. It's what resources can you recommend with deeper information to get started?
Excuse me, I didn't understand.
What additional resources could you recommend on that topic? So any
additional
blogs
resources.
Yeah.
So there's a Docker cookbook available from the family name is Turnbull, if I remember well. It is a fantastic small book. It's been published, I think the last edition was in 2017, but Docker container technology hasn't changed that much, apart from multi-stage builds, which has been one of the biggest changes in 2017-18. I don't know if it's been updated, but if it has been updated, I can strongly recommend that you go and you check on Google the Docker cookbook. Very, very nice resource. I've learned a lot with that. There is another Docker cookbook in O'Reilly from Sebastian Goasguen. He's a friend of Vision. He lives in Geneva. He's the creator of a serverless solution for Kubernetes that it's fantastic, that works on top of Knative. And he has written the Docker cookbook for O'Reilly, and it's really good as well. So please get a copy. Well, I mean, these days, it's more complicated because you got to take a subscription, I guess. I don't know exactly how it goes. But yes, please check them out. These are very, very good books for Docker. Yes.
Okay, perfect. Yeah, I can only confirm like the Docker cookbook. I think that's one of the first things you need to check if you want to get familiar with it. So thanks for this answer. The second question, maybe we need to put it in some context, but it's are there any limitations in terms of performance or number of environments you can use? I'm not sure if in what context it is asked or on what slide, but maybe you can connect it to something.
Limitations in terms of environments. I wouldn't know what to say because the word environment can have so many meanings. I wouldn't know where to start. Maybe the person who asked the question could probably write quickly clarification. I would be glad to answer. But like that right now, I don't know exactly what is it.
Yeah, perfect. Okay, maybe yeah, to the person who asked, maybe you can clarify the question a bit.
Exactly.
And Robert is asking, first he says, thank you for the presentation. And then he's asking, are you using containers as well as actual working environments for developers, like building and running your apps inside the container?
So that's a very good question. And actually for that, we prefer Vagrant in general as an option for this kind of ready to use environments that we use. I think some of my colleagues do run applications used for their workflow, but I personally don't use Docker that way. The use that I've shown on this presentation is basically what I use most, which is basically creating a container that contains a particular application that has to be shared among all of us, and basically then wrapping it with a make command in the make file, and then you just make this and make that. And this basically, it's more like a composition kind of thing. So each tool in a very Unix way does one thing and nothing else. Although that thing can be very complex, but it's one thing. We can very clearly define what it is, and then we basically compose our workflow using all of those tools. I personally prefer that kind of approach in general. However, for more complex environments, ready to use, we prefer Vagrant. As far as I can tell, that's what we use.
Okay, so Robert, I hope you are happy with the answer. If not, then you can ask another question. Mohammed is asking, also he's saying, thank you, Adrian, and for the fantastic presentation. And he's asking about any tips on init containers and also any tips on building containers from within a container.
So actually as far as I understand, GitLab CI is using Docker in Docker for all of that we've seen and can be done with GitLab CI. In terms of init containers, I'm not an expert, so I cannot give an answer on that. As far as I'm concerned, I've never worked at that level, so I cannot tell much more on that.
Okay, fair enough. Another question. Aren't network connection a pain with containers? We have a web app with Cloudflare services and Google Firebase database. Routing is still complex.
Yes. Then it's a very simple thing. In this context, most of the tools that we've created internally, some of them expose a port here and there, and that's it. These tools specifically are not meant for long-running processes, if you see what I mean. More like one-shot kind of things. I want to build this documentation. I want to lint this code. I want to create some specific version of this or that, and then the tool goes away. So I do understand the pain of networking and Docker Compose and all of that. Kubernetes brings yet another answer to this issue. It is not easy, but in this context, I gotta say that thankfully, it's not one of the main problems.
Okay, and yeah, the questions are just flying in. So there is another one from Manfred. Do you have any tips on moving volumes together with the container?
So what we do in general, no, we don't move volumes together with the containers. These containers are self-sufficient in the sense that we copy whatever it is required by the tool inside of a file system of the container, of the image, end of the story. We don't move any separate volumes, so not in our case. What the approach that we use, which is the simplest you can think about, is literally if you have, for example, the example I mentioned previously, if you have a container that has to build a PDF with colors, styles, fonts, images, just put everything inside of those container images, ship it with it, reduce the number of dependencies, and this is the core issue that we try to address with containers. It's basically all of these things can be so complex that sometimes you need not only Ruby gems, you need maybe a couple of NPM libraries because you are using something that is really cool, available only on JavaScript, and so on. So basically, we just put everything together, and we simplify the lives of those who would like to use that application. We are not, to answer your question, we are not bundling separate volumes or stuff like that, or attaching them for that matter. The only work we do with volumes is the usual Docker run and then -- volume, and you specify usually the present working directory to the internals of the container file system. Usually as well with the RO parameter at the end, because sometimes you just need to read, you don't need to write. Many times you just generate something on top of something. So the read-only parameter is it's a very good option as well. But that's basically what we do.
Okay, perfect. Thank you, Adrian. This was the last question already. Thanks for joining. We are moving ahead. I hope the weather in Zurich will be better anytime soon.
It's Zurich, you know, we don't have high hopes for that. It's okay.
Yeah, yeah, in Vienna as well. Same here.
Thanks for having me.
Thank you again. So, dear developers, we will do a short break, 5 minutes, and at exactly 4 p.m. we will start with our next speaker, Liviu. He will talk about GitOps and operations by pull requests. So looking forward to see you again. See you in a couple of minutes. Bye bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Okay, welcome back. I have here Liviu with me. Liviu, how are you? You're okay.
To start the presentation.
Perfect. So what will we learn from you today?
So I'm to talk about GitOps, like how it's made possible in a Kubernetes cluster, and then an actual tool that implements like all the GitOps concept called Argo CD.
Okay, perfect. Liviu, the stage is yours.
Great, thanks. Great, so welcome everyone. Like for the next 45 minutes, we are going to discuss about GitOps, like what makes it so interesting and what makes it so successful, because like there's a lot of discussions nowadays about this concept. And we're going to see also a tool called Argo CD that kind of respects that the GitOps principles behind it and tries to implement them. So it's going to be interesting with lots of demos. So a little words about me, like to tell you the context, where I'm coming from and what I'm doing so far. So like I have a developer background, and I started with .NET and some JavaScript, but somewhere like probably like in 2012, like I transitioned to this. I started the transition to this DevOps culture because just somebody had to do this. Like we were deploying on AWS, and it wasn't possible anymore to go, I know, to like 20 VMs and restart the service, because like I tried to do it manually and your whole day like was wasted. You couldn't like work anymore. So that's when I started the transition, like played with tools like Ansible and then like Terraform. But then in 2018, I joined Mambu, where I'm now like a tech lead in the SRE team of release engineering. And what I'm doing there is mostly writing code for operations. So I write Go and sometimes I write Bash. And in Mambu, we started with this GitOps approach, and we adopted a tool called Argo CD. And then we needed some features for Argo CD. And then I took some features like on my own private time. And this how I became a contributor to Argo CD and other Argo projects. And then Argo CD joined the CNCF. And that's how like it led me to this role of CNCF ambassador, because like I was ticking all the boxes. So great times. So in the next 40-45 minutes, I'm going to explain a little bit like about Kubernetes platform. So we are going to look at it from different angles, and we are going to lay brick on brick and try to understand like how this platform became like so convenient for the GitOps concepts. And then we'll see what GitOps means and like what the GitOps operator is. And then we're going to see some Argo CD features, and we'll end up with like a big demo to show like how Argo CD can self-manage itself. We'll see how it can handle like external clusters to work them with. And an interesting pattern called app of apps, like which will allow you to install like different applications in the clusters. Like you'll see how we can have a tree of applications installed. So that's what we're going to do. Just this thing. Okay, so back in 2018, even like before I joined Mambu, like Mambu had a monolith and it was running it on VMs. And the goal was something like we needed to start like new additional features, like new things. And the monolith had a pretty low deployment cycle. Like it was not deploying as fast as possible to production, not getting to the market, not getting that feedback that you need as fast as possible from your clients. So the idea was like, let's try to do this with microservices, like new things that can start aside the monolith. We can try to do them with microservices. And kind of like the decision was, okay, after you go with microservices, like containers seem like an obvious choice, because like you cannot run a microservice on a VM completely. Like it's much better to run it like in different containers. And then of course, like you need a container orchestration, because that container needs to be scheduled on different VMs, like needs to be moved from a different VM to another when they are closing, they are starting. So you really need a container orchestration system. Now the question is like, was this our only option? And sometimes the question is obvious, like, did we consider serverless or not? And the idea is like, if we have adopted serverless, it would have been like a big revolution, because we would have need to change a lot of flows from the monolith. Going to these microservices and this Kubernetes approach, it made us think that the monolith can be seen like not a microservice, but more like a macro service, and it can still be run in Kubernetes. And today it happens like this. So we still have the monolith running in VMs, and we have the monolith for some newer clients running in Kubernetes, in containers. And it's in production and it's going okay. And soon we are going to transition it. So this is kind of like how we got to Kubernetes. And so initially, we need to talk about Kubernetes like a big API server. Like think about it, it's an REST API server, and it has a database behind. Like usually it's etcd, but not necessarily. This is the default choice, but sometimes it happens to like have other implementations. So it's not like necessary to be etcd. And this REST API server like exposes you all the like normal HTTP verbs, get, put, post, and they have like a list of resources, pods, config maps, deployments, replica sets, and you can do changes on them. Like you can update them, create them, you can get the details, you can patch them, of course you can delete them. So all kind of changes you can do to these resources on the API server. And this API server also has like an API specification, and it's a Swagger specification, like the whole name. And so you can build your client from it. But it's not necessarily, because there are many SDKs in many language. Somehow like the Go language has an advantage, because this API, it's also used internally by components of Kubernetes to access all the resources inside. So whenever it's a new release of Kubernetes 120 being deployed, also the client version is a new client version is being deployed that works inside with 120. But from what I know, also like Python and Java clients are also being pretty close to the flow, like very up to date, maybe deployed like in the same time, like released in the same time. So the new version. So you get SDKs in quite many languages, and it's easy to interact with the API server. Whenever you do like a command kubectl get pods, that goes to the API server. It does also the authentication and authorization for you behind the scene, and is able to get the stuff from the API server and display it to you. Next, we can think of the cluster as a series of microservices, a list of pieces that work together and do some interesting things. So I'm not going to dig into details, but this is how these all kinds of controllers, we call them, and you'll hear this word a lot, work together to schedule pods, start new instances, and so on. So let's look at the yellow part. So here we can see that we have the replica set being a producer, putting in a queue that we need to add one more pod. And it's like its job is done. And then we have the scheduler. And the scheduler picks up from this queue, and this time now it's the consumer. And it sees that it has one pod to start it. And this pod needs to be assigned to one node. This is the scheduler job. Just takes pods that need to be assigned. They are like in a pending state, and then they need to get on one node. They need to get assigned to one node. So it's just this assignment that the scheduler needs to do. And it will try to do it. And it might succeed or not, because there might be nodes available, but they might not have enough memory or CPU to handle that pod, or it might be able to do it, or it might not be able to do it. If it's able, then the scheduler goes to the last entry here and becomes now producer, binds the pod to one node, and the node has like kubelet running there, and this is responsible of picking the pod assigned to its node and start talking with the container runtime and starting actually those containers from the pod, because it can be more than one. So we have these pieces talking asynchronously to each other, and we see that sometimes it's possible that some of these events might be missed. We might lose some of them. We might not be able to react on some of them, and we will see what happens with such events that might not be processed or might be lost. And kind of like the third brick is this control loop. So you'll hear these words of controllers a lot, Kubernetes controllers. And the idea comes from like robotics, from automation. And let's say like I have this arm, and it's like this. And I needed to bring it like this in 90%. So this is kind of what a robot needs to do. Like have this arm like this, receives a command, and needs to be like this. So just a simple action. So what it does after it receives the command is that it does the observe part. Am I in the right state? And the question is no. So next it does like this diff, and this means what do I need to do in order to get to the desired part, to the desired state. And I'm calculating, so I would need to apply some force and to push like the hand like this in order to be in the desired state. So I'm calculating what force do I need to put on the, and what do I need to trigger in there, what kind of actions in order to get to the desired state. And this is like the acting phase. I need to provide that, I need to do that acting phase. And probably maybe it will get like this. And then I would go again on the observe and see what do I need to do in order to, like, am I in the right state? So the answer is no. What do I need to do? I would calculate the actions. Then I need to apply the actions. So maybe it gets a little bit closer. Maybe it gets up to the desired state. But what happens next is, again, the observe, create the applying strategy, and then do the action. So this loop also happens for these controllers, and we'll see exactly like how it gets applied to the GitOps concept. So we started with API. Then we saw different pieces working together, kind of in an asynchronous mode. Then we saw this controller idea, this automation that always trying to get to the desired state and like never resting and always trying to apply the changes to get to the desired state. So you might be familiar with this command called kubectl apply, and this is now for declarative API. Initially, when we talked about API, usually API it's imperative. We talked about get, post, delete, put, like update or create. But now in this case, we have a declarative API, which means that I'm able to apply with the first command, I'm able to apply to the cluster what I have in that file. And in that file, I might have like a new deployment, or I might have an existing deployment that I need to update. But this kubectl CLI and the cluster is going to figure out that for me. And it's going to calculate what actions needs to be done. So first, it will observe, then it will calculate what needs to be done, and then it will actually apply them. So you can see this concept from robotics happening here on the declarative API. The kubectl apply can also like take a directory, and everything that's in that directory can get applied to the cluster. So all the files in there, and I think it also has -r for recursive, sorry, which will go to every folder from the directory. And the third part is not a real command. This doesn't exist, and I don't think it will be implemented. But just imagine that we started with a file, we went to a directory. What about if we can apply the content of the whole Git repo to the cluster? So we can take what's inside the Git repo, take everything from there, all the manifest, and apply them to the cluster. And kind of this is happening with in the GitOps controller. Well, things are a little more complicated because Git has repos, like a repo with, it needs, it might have like private repo with different type of access, SSH key or user password, and it has references, branches, or tags. It can have different paths inside, so you like different configuration. And we'll see that in Argo CD. But this is what GitOps really is, a way to take the state from a Git repo and to apply it to the cluster. So here, like, Git is the source of truth. Here I'm keeping my desired configuration, while I'm telling the cluster to get to that desired configuration. So more like GitOps also means that this part of reaching the desired configuration needs to be done from a controller running in somewhere in the cluster. So it's not done by push, but needs to be done by pull. This is the term that the guys from Weaveworks came with. So, and this is what GitOps means: having something in the cluster that handles this reconciliation. And this is what Argo CD is. It's a GitOps controller, but we don't call it controller because controllers are the things that work with internal Kubernetes resources: pods, deployments, replica sets, config maps, and so on. So it's an operator because it works with external things, and Git repo is an external thing. So that's kind of the difference between operator and controller. So Argo CD will keep in sync what you have in a Git repo with what you want to have in the cluster. So what we saw with the observe, diff, and act apply, this is what will happen also in the GitOps operator. So it takes the manifest from the Git, it calculates them, it sees what do I need to do in order to make it happen. So I would get in the cluster to the desired state. And then it's actually happen a kubectl apply. And Argo CD, it's an open source project. It's started to be part of CNCF somewhere beginning of last year. And you can check it out. And in 2018, when we started with it, it was barely starting, but now it's full of a lot of people trying to contribute, a lot of users, and the documentation is much better. So it might be useful for you. If you have time to check it out, please do. One of the first things you discover when you start with Argo CD is that it has a nice UI. It's much nicer than this one. This is kind of an older version. We'll see it soon in the demo. And the UI is not only to see what happens in Argo CD, but it's also a good tool for onboarding people in Kubernetes, because you can see a pod, how it terminates, and then a new version starting. And you can see replica sets, how if you want to move forward or roll back to a different version. So it's very interesting and gives the people this nice UI. Of course, it's only for things that Argo CD is managing. So not everything that happens in the cluster will appear here, but all the applications that are installed with Argo CD and are upgraded and are removed, deleted by Argo CD, all these actions will appear here. This is kind of its architecture. It's a little bit older model. It's still up to date. So starting from the left, where we have like this gray user, he's able to use the UI. It has also a CLI, and those will reach the API server. So we see this gray box here, the API server, and these parts are running in a Kubernetes cluster. And the API server is responsible to modify some resources from the cluster. So like we saw the API server of Kubernetes being able to do things in Kubernetes internal resources, we said about pods, config maps, deployments. Here the API server is able to do changes on Argo CD owns resources. It has some CRDs, custom resource definition of its own. And the API server is responsible for creating such things, updating, deleting, getting, and so on. Also some custom actions. So we do that for the API server. Then we have the repository service. And the repository service, its job is to look at the repo and figure out what do I have in there. Because Argo CD can work with Helm, can work with Customize, JSONet, KSONet, and also simple manifest. So what it'll do, it will check the contents and say, do I have a chart.yaml file with big C? Then it's a Helm repo. And then it looks, what is the API version? Is it V1 or V2? It's V2. Okay, so I'm applying this with Helm free. Then what it will do, it will create the manifest. So it does a Helm template inside, which was really great at the time when we only used Helm 2, because we didn't need the tiller, right? The templates were created inside the Argo CD process. And then at the end, the application controller will apply them to the cluster. So the application controller, it is the one responsible for checking, do I have any changes in the Git repo? Checking, do I have new applications that I need to deploy? Or like, do I have new constraints? Because there is another CRD used especially for constraints. It's called app project. So it checks the Git repos for new commits. It checks for new application and for new constraints. And it will work with the repository service to get the manifest, and then it will apply them to the cluster. So application controller is the one responsible for kubectl apply at the end, because that's what will happen at the end, at kubectl apply. And we can see here that all these Argo CD pieces, they run in this central cluster, but it is possible to deploy to different clusters. So we are not only deploying to the cluster where Argo CD is running, we're also deploying to external clusters. So and this is like pretty good, especially for Mambu, which is a SaaS business. and we have different clients with their own installations, sometimes even with their own AWS account or other cloud accounts. And for that, needs that they have their own clusters, their own installations. And for us, it was important to be able to deploy into their cluster from a central location to manage those clusters. There's also a possibility to have sync hooks. And that means like if a deploy failed, you can get a sync hook saying, okay, so I have a problem. You can put a message on Slack. Or if it went okay, you can say that I have a problem. Sorry, everything went okay. Okay, time to celebrate the deployment went okay to production. It can also go to monitoring apps. It can go, I don't know, to do apps and so on. So the sync hook is pretty configurable. You can put scripts in there and they will be run and everything will happen. And this API also, it also supports like Open API. You can work with it with like you can create your client and work with it. You can use it via CLI. There is also the possibility to controller checks every 3 minutes if there is a new change in the Git repo, but you can also have a hook, and Argo CD understands the main Git providers, GitLab, GitHub, and Bitbucket. It understands the hooks coming from them, and you don't need to wait for those 3 minutes. If you configure the hook, it will start applying the changes from the Git repo immediately when it receives the hook. So this is kind of the main architecture. There are other parts, but that's enough details. Other interesting features, it's single sign-on. This might seem like a simple thing, but it was really important for us, and I think for other big companies, it's really important not to have another layer of users that you need to handle. So you can use your Google accounts, your GitHub accounts, Microsoft, and so on, to be able to connect to the UI or use the CLI. We already saw it can be installed centrally and manage multiple clusters. So this is a really good thing. I need to underline it. We'll see in the demo the declarative setup and how it can update itself. And there are also things like sync waves, sync windows. Sync waves is I want to deploy this part, this deployment first, and second part, it will be the config map. And there is a big community. You can go online and ask on Slack channels if you have problems. There are meetings happening once every month. There is a roadmap, like new version is 1.9. So you can check out what is on the roadmap of 1.9 and so on. And you can, if there is something interesting, you can be an early adopter. Okay, one other thing to mention is the GitOps engine. This was something introduced in 1.6. It was initially started as a joint venture between Argo CD and FluxCD. FluxCD being the other solution from CNCF, initially started by Weaveworks, but now a CNCF project. And FluxCD is the other solution that you can use to apply GitOps. And this is a common library that was taken outside Argo CD, and it is like the core. And what's nice is that in November, I think, GitLab announced that they have a Kubernetes agent, and inside that Kubernetes agent uses this GitOps engine. So it's really nice to see more relevant companies coming to adopt the GitOps concept. And one other thing, usually controller is only one instance because you don't want to mingle with the state. But in 1.8, it was introduced a sharding of controllers. So you have one controller that it's taking care of, let's say, 1/3 of the clusters. Then you have another controller that is taking care of the rest, or you can split it in 3 or 4 and so on. So it allows us to have multiple controllers, because controller was kind of the only thing you could not scale, and it was creating problems, especially for big installation, like when we have more than 2,000 and apps, which Mambu is pretty close to that, or like when you have more than 100 clusters. And yeah, let's get to the demo part. So in the demo, hopefully you can see my it's okay. I think it's better like this. So I have this repo here. It's called Argo CD config. You can find it here. And inside here, I have an install file. And I'm going to start it. Usually, I just run those commands one by one. But now, because I need to hurry up a little bit with the demo, I'm going to start it, and then we can look exactly what is in that file. So this way we will go faster. So what we'll do, we'll create a kind cluster. And in this kind cluster, we'll install Argo CD 182. And the installation is done with customize. So we are going to this Argo CD folder in here. There is the customization.yaml. And you can see that the base goes to Argo CD manifest version 1.82. I'm also doing some changes here, like adding the Argo CD namespace and adding some additional stuff into some config map and putting DEX deployment to 0, because this is used for single sign-on and we don't need it right now. And I'm trying to use every piece of power, because I will start also a second cluster, and with all the presentation, this will be a little heavy on the machine. Okay, so it is installing Argo CD. Then we can look. So we have the first application being applied. Actually, I think first is the project. But let's look first at the application. Not this one. This one is being applied. So we have an application. It's called Argo CD. This is the custom resources that I was talking about. This is the custom resource definition. And this application will go to the default server, like in cluster, and on the namespace called Argo CD, and will install what it will find in this Git repo on this branch master and in this path. So it will install what is in here. And we see here, like, sync policy, it is automated, and prune false means that it will not delete unless I will do it manually. So this is what means, because deleting is a little bit dangerous. You can do really nasty stuff. So initially we installed it from here, from this Argo CD folder, and then we tell it, okay, you can go and you'll find an application there, but it's already installed, so it will calculate, like we saw, it will calculate the diff, and we'll see that actually there's nothing to be applied. But from now on, after having this application deployed to the cluster, it actually creates this link between the Git repo and the cluster state. So whenever I will do next a change in the Git repo, it will be picked up automatically and deployed into the cluster. And this will be our first change. Then we take a look at the app project. This is another CR, custom resource. And we see that the app project can be used to define some constraints. So for example, I can say that all the applications that use this app project can only deploy to the default cluster, can only take stuff from this Git repo, and there is no restriction on namespace. I can add, and you can also start adding some restrictions. For example, I can blacklist something and say I will not allow it to create secrets, because secrets should come from an external source. I can do that, or I can allow it only to create deployments and not stateful sets, because that's what it needs to do. The application that use this project. So we can see here that we have the project defined here, which project this application to use. Following on, this will get the binary, the CLI. It calculates if it's Linux or Mac, and it gets the binary 182, and actually it will put it like this custom. So if you have already Argo CD, it will just put Argo CD minus 182. So it will not do anything if you have already installed the version. And then it takes the password, the default password for the UI and the CLI, and it will display it here. So it generates a password, which is actually the server pod name. So let's see the state. Okay, great. So we have it running. We can check. Run. Okay, so try to connect. It cannot yet, but we see that we have the version 182, which is great. So next, we'll go into the self-managed cluster. So we did these actions from here. Now we just want to connect to the Argo CD UI. So I'm going to do a port forward. Okay, the pod is not up and running yet, is in pending. Okay, great. Hopefully I will be able to. Okay, this gets the admin user, but we are okay with, we have it listed there. And so if now I go to localhost 1995, okay, it will tell me, because in this case, the certificate is auto-generated, but we are okay, we are on localhost. I need to add my password in order to accept it. And we saw user is admin. And we saw the password being written here. Nice. So let's put it here and let's sign in. I don't want to save it. So now we also have the Argo CD application, which we installed here. And okay, we have an error probably. Yeah, it gave a timeout, but we can always try another sync. Or not, let's do a refresh. So refresh is kind of the same thing, but it will not try to apply it automatically. So it gets content from the Git repo. Sync will also try to apply it automatically to apply also the sync. So this is kind of the difference. So when sync is not available because it didn't find anything, we can go with refresh. So what we are going to do next is we are going to modify this version. So instead of 1.82, we're going to upgrade to 1.83. So this is the change we are going to do. Only this. We can see here that the version is 1.82. Yeah, it's going a little bit slower. Okay, let me do that. Okay. Let's see, do we have any questions? What needs to be done in terms of security? So probably you are referring to the default password. So you can change the password after you install it. In our case, we use single sign-on. So the admin user can actually be disabled. Okay, great, it started to sync, so we can have the first demo at least. So the admin user can be disabled, and even when you'll get the UI, you'll not have like any text box to add the user or password, anything. There are also local users
Dear developers, we have a small technical issue. We will be back in a minute. Just a second.
So sorry about that. It was a connection glitch and I got disconnected. So we are talking about security and the fact that we can see here the default password is kind of the pod name, which is the default password. So you would need to update it. If you still use the admin user, you need to update it to something more serious. Because at least part of the pod name can be guessed, the first part. In our case, we are using single sign-on, so actually disable the admin user. And there are some local users you can use, and you can configure with different rights for doing automation and single sign-on for your real users. And single sign-on is able to, you can use it from the UI. And when the admin user is disabled, you don't have like text box to enter a username and password. You only have like SSO login, what you have, Microsoft, Google, GitHub, and so on, whatever you set up. And you can also use it in the CLI because you have like a -SSO flag. Okay, so what I did right now is I created the installation of 182 and I linked it to the Git repo. You can see here the commit, and I also pushed the commit that modified the version from 182 to 183. So this happened while I was offline and I was having fun upgrading. So it actually, you can see here that it changed the commit from CB6 to 3D5. So Here we still see CB6. So I will try to sync it now. I will not let it do it automatically. And it should see like it's out of sync. It takes a while, and my laptop really struggles to put to take this and make it work. Okay, hopefully we don't have, because initially I had a timeout on connecting to GitHub. So meanwhile, I can show you the CLI. So I was able to log in with the CLI. You can see here, I was able to log into this server here, putting in secure because the certificate is auto-generated and username and password. And I was able to run this command uplist, and it gave me the list of applications. So in my case, it's just Argo CD, and you can see repo, and you can see the status is synced. So it brought the last commit from Git. So, okay, great. So now we see that it's out of sync, and probably it already started to deploy, or it should started. Okay, let me see. Everything is slower now. So probably now we just need to wait to see different pods spinning up with the new version, and 1.8.3 will appear here. Unfortunately, I will not have time to go to the second exercise. Okay, let's see this syncing. Maybe now it will be. But I can tell you about it. You can clone the repo and do it yourself. So I was starting a second cluster. There is some workaround if you are working on Mac. There is a problem with kind. It depends also on your version, but if you have latest 2010 Docker, it is a problem. If you have 19 something, it's not. Anyway, if you run this, it will not be an issue. So it will just, if you don't have the problem, it will not do anything. What I need to mention is here in the dev cluster, here you will need to put your own IP. So this is my local private IP. So you need to put your local private IP, because otherwise kind listens on localhost. So you will not be able to tell Argo CD in its own container to connect to a cluster on localhost, because it will think its own namespace localhost. So that's why it needs to be like a real IP. So that's why here you just need to like clone this repo, put your own IP locally, and you can, and also here. So whenever you find a reference, modify it, and then you just run this, and you have the second cluster. And I'm explaining here what you have in the second cluster. And then here was the installation for the second cluster. So you just need to run kubectl apply these two items, and you'll see them appear in the dev cluster. It would have been great. Sorry about this. So let's see if we had any luck. Well, it's trying to. It's still 0 out of 1. So yeah, demo gods were not with us today. Need to bring a sacrifice. My laptop probably. So let's see. How do you monitor or service in production? So it provides Prometheus metrics. And I will yeah, so I see also the monoreps. So it provides Prometheus metrics that you can scrape with a Prometheus operator or any other thing that supports Prometheus metrics. And things to monitor are usually, we tend to have big applications that takes a lot of time to deploy. Like think about Istio. That's really huge application. But not only, things like ingress controllers, and maybe if deployment of microservice is not that big. But the idea, you can like create a baseline for how much time it takes to deploy it. And then if it takes longer, if it goes with a threshold like 10%, you can already alert on it, or you can put different things there. So this is kind of the things we are watching. And over the versions, the last version, Argo CD really improved its performance. And this kind of made a difference. For example, 1 year ago, we got a lot of complaints from development teams that things were progressing really, really slow, and they were not able to maybe meet their client requirements because you have a different window of deployment, but now it's in a much better state. Yes, you can use mono repos with several apps. So in our case, there is one repo that has more than 10 apps. We don't use mono repo, but it is possible. We have one repo with more than 10 apps. And that's because we are using this app of app. So I'm just going to explain what would have happened if I would install this application. So it would have went to this repo, to Argo CD deploys, to main branch, to the apps folder. And in the apps folder, it would have find not actual, let's say, Helm charts or manifest. It finds, again, some applications. And those applications can even go to other applications from the same repo. So I can have here apps, and then I can have here, I know, a second level of apps. And anyway, on the last level are the actual microservices that you want to deploy in production. But you can have different levels in the folders, right? So I can have here Argo CD deploys apps, and I think I have Argo CD, not this one. This is kind. So Argo CD deploys was here. So you can see that in apps, I had another app, which is pointing to Nginx folder, still from this repo. So using folders, you can create a tree of applications. So you can use a mono repo without any problem. I don't know, you'll probably at some point run into problems. I cannot say because we don't use them. Probably performance, because it's only one repo. So Argo CD, like if it sees a commit on that repo, it will see that, man, I have a lot of applications to sync, because it doesn't know exactly what to sync, what changed. So it needs to calculate a lot of applications. So those repo servers, you can scale them. So I know you can put 20, let's say, it's not a problem, or 50. Why not? Nothing will stop you. So hope I answered. So I don't see any other questions. And we can look back here. It still didn't start, unfortunately. It's a problem of resources, even though I assigned a lot of CPU and for my Docker VM, but okay, it didn't work. It's still in progressing. So any other questions?
Hi, Liviu, Seat here.
So I guess we can wrap up.
Yes, I would say, like, even if DemoGod was not on our side, I think that the concept is well understood. It was a very good presentation. Thanks also for answering the questions from Slido on the fly. Let's see if there is more to come in. If not, we can wrap up. Yes.
Sure. So yeah. Thank you for
Do you have any closing remarks, or do you have any resources that you want to share? Like where can people find more information and maybe read something and so on? Just to repeat that.
Yeah, so the main resource would be like the Argo CD repo, and from there you have the documentation, and there should be the Slack channel somewhere, because there is a Slack. Maybe it's here. Let's look for Slack here. So you have here like join us on Slack. So go to Slack. There is Argo Dev for development issues. There is Argo CD. Argo has also other apps. There is Argo rollouts. Argo is like an organization, and Argo CD is just one of the applications. So if you have other questions, join on Slack. There is also GitHub discussions. This is something newer. You can take a look. Something like here. So it's happening. This is more topics based. So you can see something here. So it's a little more organized than Slack, because in Slack you ask something and then 20 more people ask something, so you might lose it. But here it's a different concept. So.
Okay, perfect. Liviu, thank you so much for joining us. I hope to see you in the future as well again. Greetings to Iași in Romania, right?
Yeah, thank you. Yes, thank you. Thank you very much.
Yeah, so for the audience, if you have any other questions to Liviu, you can also ask us, and we will provide him with the questions. I'm sure he will be happy to assist and to help. And other than that, we are making a quick break for only a couple of minutes, so enough time to get another coffee. And then we will be back with a talk about how to write secure Dockerfiles. So see you in a couple of minutes.
Bye. Have a great.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back, developers. So let's kick off our last session for today with Madhu, our last speaker. Madhu is working at Miro. I hope you know Miro.com. It's a wonderful tool. We use it at WeAreDevelopers as well. And he will tell us about how to write secure Docker files. Madhu, how are you?
Hi, I'm doing good. How are you?
Fine as well. So Madhu, what will we learn from you today?
Yeah, so this topic actually I most of the time talked about containers and Kubernetes security, but today we will deep dive mostly focused on Dockerfile itself, like how do you write and secure Docker files to make sure your entire workflow is secure enough using like a Docker files.
Okay, perfect. Madhu, the stage will be yours in a couple of seconds. So yeah, I'll get out of the way and see you later for the Q&A session. Bye.
Thank you. Hello, everyone. Welcome to the final talk of the WeAreDevelopers Container Day. So today in this talk, we will be going a deep dive into writing a secure Docker files and using some kind of practical approaches by following different tools, linters, and techniques and validation methodologies. So before moving on, a little bit about me. I work at Miro and leading the security engineering, focusing on mainly cloud native containers and Kubernetes infrastructure. And apart from that, I have been tinkering and doing a small little open source projects like Kubernetes. I have created in terms of designed to be intentionally vulnerable cluster to play and learn about Kubernetes security. Similarly, Hacker Container, it's a simple Swiss Army knife of kind of tool to play and assess Kubernetes clusters in security environments. And I'm fortunate to speak and train at a bunch of conferences around the world, like Black Hat, DEF CON, Usenix, and OWASP, and some of them. And I have also written a book on security automation with Ansible, which is trying to help security people using the power and leverage the Ansible to automate their day-to-day tasks. And I keep learning new things, so that's why I'm a never-ending learner. And if you wanted to know more, and you can follow me at Twitter, Madhu Akula. So let's go ahead and dive into the topic. So today we will be mainly focusing for the next 30 to 45 minutes on the following sections. So why actually we have to focus on Docker, right? And what is Dockerfile itself? And why we have to think about security of Docker files, because they're just a static files, right? It has like instructions. And what are some of the best practices for writing Docker files and utilizing some of the tools like available open source linters and your VS Code or like whatever the code editor plugins, and how you can integrate this in your day-to-day workflows like CI/CD or GitOps approaches. Right? And also we will go ahead and think about writing policies using something called Open Policy Agent. We will discuss a bit later. And using Rego policies, we can create our own custom policies to perform and validate these best practices against our Docker files. And we will also look at simple open source utility I have created called Docker Security Checker, and how we can use this Docker Security Checker to perform and validate security best practices against Docker files. And then we kind of conclude with how you wanted to go about next steps and leverage more power of OPA and Rego policies to build and secure your environments. And that's kind of the things we are going to look up. Right. So what is Docker? So I think if you have been hearing quite some talks for some time, you might know about what is Docker, and you have been seeing like some Docker related activities, especially Docker files in the previous demos talks. And Docker is an open source platform for building and deploying containerized applications. So it became a de facto standard right now to build and share containerized applications. It can be from your developer laptop, or even it can be in cloud environments, or even edge devices like Raspberry Pi are also, right? So Docker enabled one of the key thing, it enabled developers to easily write a container and package their application code, its dependencies, and the environment into a container, which is portable. They can ship it anywhere, literally, which means like its production environment, staging. So they don't have any differentiator. So what we will be looking here today is Docker images can be built automatically by reading something called Dockerfile instructions. So we will see how these instructions are created and how we can securely create those instructions so that we are creating a container, secure container images and running them in our production infrastructure. So if you look at a typical Docker file, this is how it looks like. This has been taken example from the wood sample example. So a Docker file is a text document which contains basically all the commands which we wanted to tell and assemble an image, right? So if you look at a bit here, you can see we are using a Python as a base image, like which means we are pulling the official Python image. And if you see a little bit more, we are using specific tag, which means Python has different types of version. So we wanted to use only 3.9 version, which is what our code is written towards, right? So these kind of things we can clearly declaratively mention in Dockerfile. And similarly, we can say that once we pull the Docker Python image, we wanted to install some specific packages like curl here in this case. And then we wanted to install dependencies for our application code and copy our application code into the container environment and expose that application environment to the outside using the port and run this command, right? So this is how a typical Docker file looks like. So then we know now it's like nothing but a bunch of instructions of written into a text file. And why do you think about security, right? So some of the things why we need to focus on Dockerfile security is Dockerfiles are the blueprint for building your Docker container images, which means these are the like committed into your version control along with your application code. So these becomes your blueprints. If you wanted to build a strong infrastructure, you have to have a strong foundation, right? Similarly, you can use and build secure Dockerfiles, which can impact and perform better security in later stages, right? And Dockerfiles are basically codified version of your application and infrastructure, which means nothing but your infrastructure as a code. It becomes one of them, right? And Dockerfile is one of the key component when it comes to supply chain security attacks. Like if we have a misconfigured Dockerfile or we have some secrets, sensitive information which committed to GitHub, if an attacker able to obtain those environment keys or maybe the AWS secret keys, they basically not only compromise your Docker container application, they can completely access your entire cloud infrastructure, right? Which means they can gain complete access to your AWS, right? So this becomes one of the key component for the entire application security or infrastructure security, right? So another one of the main thing is there can be many possible security issues which can leverage from the Docker files. So we just did a quick search on GitHub for the Docker file. We can clearly see 2 million above like files are committed in the GitHub nowadays, right? So I think most of you have already started doing some of the best practices for creating the basic and secure image, right? So these are some of the best practices we have taken from the Docker itself. Like if you have been using containers for quite some time, most of you might have been already using some of these. So just to quickly recap, what are the best practices from Docker itself, like the suggested? Start with the small version of the image, which means don't go ahead and download your entire Ubuntu base image and go ahead and install your Python or Node.js or whatever the runtime and build it. Why don't you go ahead and pick the Python base image, which is official available, so it becomes much more smaller version. And also you don't need to have the Python of the larger image. Maybe you just wanted to have the Python runtime, so you may wanted to pick the Alpine version of the Python image, right? So building these will reduce a lot of unnecessary packages, and which means you don't have known vulnerabilities maybe in other software which might not want to use, right? And creating ephemeral containers, which means in this context, you want to be able to reproduce this entire building of image at any point of time. The Docker file should be written in such a way so that you can recreate whenever you wanted to recreate the Docker image, right? Understanding the build context is very important. I think most of the developers miss out this part. So whenever you are trying to build the Docker container, it doesn't matter if it is from your terminal or in your build environments like CI/CD pipelines. So wherever you are running the Docker build command, so the entire current working directory from that recursively, all the files will be added to build context, which means if you have any sensitive information, which is already part of your build context, right? So excluding some of the files which you don't want it to commit or add to the build using Docker ignore, which is similarly how you do Git approach like Git ignore, would be very useful, and it removes a lot of better practices. And this is a recent, not quite recent, it's been there for some time, using multi-stage builds. This is one of the useful feature, especially if you wanted to just take a binary out of the entire build, right? So you can use multi-stage builds, saying that go ahead and build this Golang code base and generate a binary out of it. So you can use another stage where you can just take that artifact and use it from scratch image, right? So the main reason using these multi-stage builds, so we will only take what we want, like we just wanted to take that jar file or maybe the binary of the Golang or some other program, right? So we don't need to have all pre-built packages which may have known vulnerabilities and security attack surface. So we can reduce these by using multi-stage builds. And this is, I think, a common pattern. It doesn't only for containers. In general security, don't install unnecessary packages. If you don't require something need to be there in the container image, please don't install them. As long as it is bare minimum required, you just need to be having like enough required softwares, right? So this is not purely security, but in general useful practice, like minimizing the number of layers and creating a lesser layers so that it kind of reduce the image size as well when you're using in running in the infrastructure, right? And this I'll go a bit deeper little later, creating multi-line arguments, which means it is useful for the readability, and also it kind of reduces the layers. Again, it goes back to the previous point. And the cache part, this is quite interesting. Sometimes you might want to use cache to improve the performance and to improve the faster builds, especially in build systems. And sometimes you don't want to use cache and build from fresh, which means if there is a security vulnerability, maybe the local cached version might not have fix for that. So you might want to pull the fresh from the upstream, and you don't want to use the cache. So this can be need to be context driven. Sometimes you might need to use cache to improve the performance. And the last thing, create your own base image like golden images. If you are coming from the data center or cloud world, you use golden AMI or golden image where you have restricted or hardened image. So you can similarly create your own golden images for the Docker as well, right? Which can be put as a base image. I think these are some of the quite high level, and if you go generically in terms of security, you can even delve into a lot of security best practices out there, which are theoretical, and it is very difficult to validate and perform in your day-to-day workflow, right? Some of them, if you think of them, don't use copy instead of using copy, right? Instead of add. And copy only specific required files, because most of the developers we have seen in development workflows, they just copy the current directory, entire thing into the Docker itself. So you don't want to copy everything. You just wanted to copy what exactly you will be going to use for the application, right? And performing the same command, like rather you performing the apt-get update as a different run and apt-get install as a different run command, you can combine these in a structured way, and you can run in a single layer in the Docker file. and also installing only what we need. Suppose if you are installing a package like OpenSSH client, maybe you don't want to install just everything. It's you can use flags like no install recommends, which kind of prevents unknown packages which we don't need, like suggested packages by package manager. And once we have installed packages, clearing the package manager cache is also good practice, which reduces again like image size in terms of. And don't ever use latest tag, because if they have been updated, it kind of go ahead and pulls the latest image from the registry. It's always better practice to use the specific image tag which you wanted to use. Even if you required, go ahead and use the full SHA sum, like which means the long ID as well, right? And this is kind of security best practice in general. Do not run your containers with root privileges or root user and group. If you wanted to install some packages, go ahead and install with specific root user, then change it back when it comes and running with the normal user privileges, right? And these are some more best practices like you might have already seen. Only use trusted images. Don't use like some third-party images which is unknown author built, and use official images. And try to prefer using base images as minimal as possible. And this is one of the key components, not only specific to Docker, in general security. Most of the developers try to keep the secrets copied into Dockerfiles, or maybe the files which is going into copied into the Docker container. So this becomes one of the biggest security risk in general. If your Docker container registry got exposed to the public, and any one of the attacker able to gain access to your container registry, they basically have your access to secrets and sensitive information. So do not store your secrets or sensitive information either in Docker files or not even in the container files which you're going to copy or add. And don't install and expose services like SSH in the Docker files, which basically increase the attack surface to your containers. Right? And performing lifecycle management, whenever you wanted to patch and update, you keep regularly managing these things as the best practices, right? Cool. So this is how a typical example looks like. This I have taken example from the Hexa, simple Docker file which has the best practices. So here we are trying to use the Alpine. Again, I think there is a simple mistake. We don't want to use latest. We want to use the specific tag, and run the specify with the non-root users, non-root groups, and also don't install with the cache here example. And they're also using tiny and exposing the application with non-root users, right? So these all are simple to talk, and we can theoretically use a better practices way, but how you can enforce these in automatic or programmatic way, right? In a practical approach. So this is where we kind of use some kind of power of tools and techniques and methodologies, right? So if you have been following Docker closely, they have released quite some time back something called BuildKit, I think, which is now officially stable part of Docker, which is a toolkit for converting your build artifacts in a secure and performant way. So I think if you have been using Boulder, I think you have to use export the BuildKit option. And I don't know about the Linux. I think Mac, they have by default enabled this option right now in the newer version. So one of the key things in terms of security, BuildKit has two better options. One is especially for passing the secrets when you are building container images. And also the main one of the good use case most of the people struggle to handle is SSH agent forwarding, because they most of the time either copy the SSH key into container file and clone the private registries, right? So we will see how BuildKit help these problems to solve in terms of security perspective. Yeah, this is an example of typical workflow without BuildKit, right? So you have a base image and you wanted to perform like AWS access key because you wanted to get some kind of data from AWS, right? So you might be adding your environment keys by adding access key and secret key, which means these are committed to your version control. It doesn't matter if a developer or attacker has access to your GitHub organization or like GitHub code base or your Docker registry, they basically have your AWS access keys and secret keys, right? Which is big no, right? And similarly, sometimes people also use as a build arguments, like when you do Docker build, you can pass the build arguments, Docker build arguments. So they say arguments and they pass docker build --arg and AWS access key secret key. Still, this is a big no, because whenever an attacker obtain this image, if they perform Docker history, they can still obtain your AWS access key and AWS secret key, which means they basically have access to, again, your entire cloud environments, right? So in build kit, you can easily pass this option by using mount. If you have build kit enabled, you can pass the secret and you can just say whatever the ID AWS, so you can perform this in Docker build, and you are mounting the root and AWS credentials from the host system into the Docker container, which is going to perform in the build time. So in this way, we don't store the AWS access key and secret keys in the environment variables, are not even passing through the build arguments. So this is kind of improves quite a lot of security benefits when you are building container images in your CI/CD workflows and don't want to give your AWS access keys and secret keys inside the containers. Right? A similar use case, but this is a little bit different. In before, developers are like ops teams try to copy the private key, which need to have access to their private GitHub or like Bitbucket or their own version control systems, because these repositories are private, which need to be accessed by using SSH key from within the container, right? So they ideally copy the key from the host system into the container, and they clone the private repository within the system, right? So which basically means if anyone has access to your container, they have SSH key or private key, which can able to, again, they can pull entire GitHub private registries or your version control registries, right? With build kit, we kind of able to do one thing, which means you have to add, by the way, the known host of the GitHub or the host to the known host. Then you can mount the SSH socket from the host system. Build kit has an option to pass the SSH host socket by forwarding into the Docker container, which means you don't need to store your SSH keys inside that container images, which means you can able to clone your private registry repositories from your version control systems without leaking or leaving the private keys in the build images, right? Okay, so this is kind of built-in features. Till now we talked about Docker. So how can other utilities can help and improve your best practices, right? So there is a simple utility called Hadolint. I think most of you might be using already, which is nothing but a Haskell-based Dockerfile linter. What it does is it kind of parse the Dockerfile and performs the checks. Basically, is it like following the best practices, or do we need to improve anything, right? So let me quickly showcase the quick demo. So if you go ahead and open the Hadolint, I will go ahead and paste a simple Docker file. So this is a simple and completely insecure Docker file. Oops, sorry. So if you click on lint, you can see that it kind of identifies whatever the best practices we have talked about. Like it is trying to say that do not use copy instead of add. We will talk about why we have to use add. Just one example to give. Copy by default copies from the host system to the Docker. Similarly, add does the same, but some of the extra functionalities add has includes. It can also fetch from an URL. And also if you are downloading a tar or zip file, it automatically unzip or extracts itself. So sometimes attacker can leverage these kind of things to, if you don't control some kind of third-party endpoints where they can host malicious payloads, they can able to easily extract and use it, right? And similarly, it will also try to suggest use no install recommends, which we just talked about, and how you can lint. So these kind of linters can be used in day-to-day practice to reduce the workflow and automate some kind of best practices. And also you can use the build CI/CD way also. If you wanted to, for suppose example, you wanted to pass the Docker file which you have in the system, so you can go ahead and run the lint. So it will go and say that this is the rule, it matches, and you are using the latest image, and they're asking to use specific tag, which is one of the best practices to use. and try to specify the specific package version. Don't just install apt-get install maybe Java or Python. You have to pin specific version, right? So these kind of best practices can be automated and added to your CI/CD workflows, right? Cool. Let's go back a bit more. So there is another utility called Dockerfiles, which is purely focused not only best practices and also security mindset, right? So Dockerfiles is again another linter kind of utility which help you to perform security best practices for the Docker images as well as the Docker files, right? Some of the things it looks primarily is CIS benchmarks, which is mainly focusing towards security. So it kind of looks for whether create a user in the container or not, or are we using trusted base image but still it need improvement, and are we have any health checks applied in the container, or are we using copy or add command, or do we storing any sensitive secrets in the Docker files. And also it has some other basic checks which is focusing on security. Are we using any UIDs and groups apart from root user, or are we using any sudo commands and some kind of other best practices, right? So you can also use this utility. So maybe I can just quickly demo if you want. So maybe I can just use the example. So if I do just Docker and the image name, the container image name and the tag which is used, so it will go ahead and perform the analysis and it returns the best practices. If you see here now, it go ahead and perform the best practices on the Docker test image and gives the results. Oh, we have found an environment key called MySQL password, which means it has the MySQL password and some credentials.json file, right? So these kind of checks you can utilize if it is a critical security issue. Maybe you wanted to block this Docker build at the same time, and you wanted to fix these security issues before you push these images to your own private registry or even your production environments, right? So these kind of simple utilities can help you and save a lot of time and improve a security posture in a longer run, right? Cool. This is another simple utility. It's not only focusing towards security and also minifying your container images. Docker Slim, which is helps you to reduce the size of the image. Like if you see here an example, when we build the Docker image for the my simple sample node app, you can see 432 MB. And when we use with Slim, it kind of reduces the layers and improves the and removes all unnecessary packages and make the image as less as possible so that you can utilize the minimal images, right? And some of the features it has includes like you can analyze and like kind of improves the instructions of the Docker, and also it kind of optimizes your entire container image. And the key part in terms of security is it automatically generates seccomp and AppArmor profiles, which can be improved a lot of security in terms of Docker containers, right? So to perform a simple AppArmor profile or seccomp profile generation, you just need to run the Docker scene and build your own container from your Docker file. Then you can run, once you run the scene, it automatically generates a seccomp profile in the same artifacts folder. Then you can pass this whenever you are running a container, or even in your Kubernetes, you can just pass this seccomp profile in the runtime. I have tested with some of the use cases. It doesn't work for all of them. Maybe you just want to try it out yourself and maybe just validate before using. Yeah, that's a small like suggestion. And this is another simple utility which may not be directly helpful in terms of improving your security posture, but it definitely adds a lot of value in terms of debugging and understanding the container images, and also in terms of if you wanted to analyze the security compromise and understand security images which you obtain from third parties, right? Dive is a simple utility which will help you to inspect layer-wise what are the changes happened in your Docker container. So which kind of gives you more visibility into your containers and gives you to optimize if you don't want to use some kind of layers, and what it kind of built. If any third-party images you are using without any source code, you're just pulling from Docker Hub, it kind of help you to understand, is there any backdoors, or like you can analyze the security perspective, right? So let me quickly give you a demo. So if I do dive and a simple example image, I'm just using a sample image. So what it does is it kind of fetches the image, which already I think I have pulled it locally, and it go ahead and analyze each layer of the Docker image which has built for the Madhu Auckland hacker container, and it gives layer by layer inspection of the container image, right? Which kind of help you to understand what kind of files has been changed in each layer, and updates has been happening. I think it's gonna take a bit more time. Yeah, let's hope it is gonna be faster. Yeah, it's done. So if you see here, first we have just used the base image you can see from, and the base image, and then we have added an extra file, like another layer, which is the another command in your Docker file, and this is another file, another layer, this is another layer. So you can inspect each layer by layer. And also if you come here, if you see a lot of changes happened in this layer, the two layers difference, and you can go back and inspect it in each layer. Like, okay, in this layer, I can see that there is a CA certificate.list file has added. Maybe we have installed APK get install CSRs or OpenSSL, right? So you can easily inspect the changes layer by layer using dive, which might not be useful in terms of CI/CD, but it is very useful in terms of forensics or analysis of the layers, right? Cool. Let me go back to the presentation. And another simple thing, if you are using any linters, go ahead and use your linter capabilities. Maybe you can just quickly use the linters from your code editors. Like for example, if you are using VS Code, there's a Docker linter which kind of performs while you are writing Docker files within developer environment. You kind of inspect for these best practices in the developer environment itself only. Cool. So we have talked about what are the possible all available tools, some of them which I know, and which can help you to improve the best practices and security. So this is something which you can customly wanted to build, right? Something you wanted to add your own patterns based on your organization development workflows, right? So that's where we wanted to introduce something called OPA, which is a project by CNCF called Open Policy Agent, which is mainly to perform a policy check. It doesn't matter, it can be against your Docker file or APIs or containers. So it's kind of general purpose policy engine, which can be used to perform a policy validation, and based on taking the input, and it validates against the policy. If the policy says success, then it says allow, or if you say deny, then it will deny, right? So we will be using leveraging OPA and see how we can construct these kind of best practices and run Docker security best practices, right? So OPA uses something called Rego. Rego is a policies. The way you write policies is something called Rego files, which are basically a general purpose like a language, which is previously inspired from Datalog, the format, how you write Rego policies. Basically, Rego takes the input as JSON and validates the policy on top of them. Right? So what we are doing is we are trying to use Docker files and apply our Rego policies, which are nothing but our Open Policy Agent Rego policies, and see does this Docker file has the security best practices. Right? So this is how a simple Rego policy looks like. Maybe it looks a bit like maybe difficult to see. Maybe I'll just try to show it in the browser. So I'm just trying to showcase a simple Rego policy. If you see here, what we are trying to do is we are using a Rego policy called role-based access control. What it has is it has some kind of input, which means like the input for the Rego open policy agent, and the data which you wanted to test against, the policies which you wanted to test. And once you test, evaluate, it will go ahead and run this policy against the data which you have provided and gives the results, right? For example, if you take an example here, the first policy is, it is saying user is admin or not. So it will go ahead and check if the user is admin, and it takes the input, which is nothing but it is coming from here. User is Elise. So it will take the input is user is Elise is not equal to admin. So it will say is user is admin is true or false based on the data which is taken from the roles which you got, right? User is admin. It is a bit confusing initially, and I think if you understand and practice some Rego, you might be able to easily understand this writing policies. And I think if you wanted to try out, I would highly recommend check out this playground. So, sorry. So what we are using on top of Rego is, so we have been using a simple project called ConfTest, which is a utility to write test cases kind of thing against structured configured data. So ConfTest has basically relies on the same Rego policies using the open policy agent, but it kind of gives us a structured data. Basically, by default, ConfTest currently supports different types of file formats. One of them is Dockerfiles, right? So that is the main reason why I have chosen the ConfTest while writing the security best practices files using the ConfTest for the WebAR, right? So this is how the policy example looks like. So you get the input and you write the policy, and if the policy is successful, then it is allowed. If it is failed, it returns the fail, right? So let's look at a simple example and write a Docker security best practices using Rego policies, right? This is the sample file I have created, which is an insecure Docker file. Like we are trying to use Ubuntu latest and put some secrets in the Docker files and using copy add instructions and also installing a bunch of packages, right? So if you wanted now write a simple basic policy, which basically looks for any add instructions in your Docker file and basically warn against them, right? So this is how it looks like, a simple Rego policy for writing ConfTest. So the message has basically the structured data of this entire Docker file in a JSON format. So this is the input for your ConfTest. So once it comes, it looks for any command which starts with add, which is the add commands which you can see here. So whenever it identifies, and also we are trying to just concatenate with the space to ensure we validate with these spaces as well. And if we find any of these commands, we are just trying to say, return a warning message saying that use copy instead of add, right? So this is how a simple basic Docker file best practices you can write using Rego policy with the help of ConfTest, right? So let's go ahead and run this as some of the policies I have created using Rego with ConfTest. And so I have put this project in GitHub, like github.com Madhu Docker security checker. So if you see here, so this is the Docker file we are trying to validate against. This is the same file which you have seen in the demo. So now if you see the policy, let's go ahead and run first ConfTest test against this Docker file. So you can see it go ahead and performs the validation of Rego policies. It identifies a warning, do not use the latest tag, because if you see here, we are using the latest tag for the Ubuntu. And we found a suspicious env key, which is nothing but a secret. And we are trying to use add command, Dockerfile best practices suggesting use copy instead of add, right? So you kind of use these policies and leverage in CI/CD and perform these best practices in terms of the security checks, right? So if you see the policies, these are part of the policy directories, and these are the Regos which you can see, right? Package main and whatever the checks which we have done for the environment variable and whatever the checks we have done for the latest image and all of them, right? So now you might have been thinking, we have already used Dockle and Hadolint or other tools. Why we have to use OPA or Rego policies, right? So this is where we will be talking about why we need to introduce custom policies, right? So one of the main reason being every organization have their own common patterns, especially if you are an organization have been running your own way of doing workflows, and you might have your own custom way of doing development, or your own way of custom way of doing operations like infrastructure, DevOps, right? So this is where OPA or Rego policies can take a lot of power. And some policy, for example, if you look at this example, so what we wanted to perform is most of the organizations might have been maintaining their own private registries and not just pulling the images from the Docker public registry, right? So their security team wanted to enforce, don't allow any user to pull the image from the public registry and only allow from our own internal registry, right? So you kind of can leverage a simple Rego policy, checking for from, if any from base image, which is not starting from your own trusted registry, which is example trusted registry here, then you can say that don't allow this kind of Docker file and deny itself in the build time, right? So this is a simple Rego policy and much more effective, which kind of prevents any developer or operations team to not use public Docker images and only allows them to use trusted and internal private registries. So this is how you can write your own custom policies, and I'm sure each organization has their own better workflows. So you kind of leverage these Rego policies to go beyond this level as well. Right? So if you are someone wanted to try out how this entire setup works like, I would highly recommend you can check out. I have created something called Katakoda workflow actually. So you can go ahead and use this Katakoda workflow to go ahead and click on the simple example and see the Docker file, the same example which I have showcased. Maybe I just zoom in a bit. Yeah. So you can go ahead and see and run the conf test, and you can write your own policies if you wanted to, and play around Rego as well as conf test and open policy agent. I hope you learn a bit more policies, and I am really looking forward if you tried, like wanted to let me know, like if you have created more valuable policies using conf test. Cool. So now we have learned like how to write best practices and how to use the tools and techniques. Now, what are the next steps you wanted to take right now once you go out of this talk, right? I would highly recommend you try to write and follow as many best practices as possible, even before you committing them to version control, by using linters and your code editors, so that it kind of reduces a lot of security mistakes in the early stages. And also try to implement these linters and tools in your GitOps or CI/CD workflows, or even your GitHub pre-commit or post-commit hooks. And maybe you wanted to create your own standardized custom policies based on your organizations and your development and DevOps workflows, which will be improves a lot of security performance. And not only Dockerfiles, you can leverage OPA and conf test to even look at the Kubernetes MLs or any other kind of supported formats. Like you can see here, it kind of supports bunch of formats. You can leverage this security best practices in any layer. That's it. So to just conclude, if you want to know more about a bunch of other security tools, I try to curate here. So maybe you might find some of the open source tools which might be helpful for your containers or Kubernetes and cloud native workflows. And these are some of the references and resources if you want to dig deeper and dive in more into the security parts of the Dockerfile. And thank you so much, everyone. And I am happy to take some questions and looking forward.
Thank you, Madhu. Very nice presentation. I'm sure the audience liked it. So I'm just checking if we have any questions. So no questions so far. Then let me ask you a personal question. Like, how did you start your career? How did you end up working as a security architect and so on?
That's quite interesting. So I have been mostly doing security from the college, which is, I don't know, it's a good thing maybe. I have been started finding vulnerabilities basically in major companies like Google, Facebook, Adobe, like whatever you name. Then once I found bunch of vulnerabilities, I thought, okay, maybe it's nice that I learned finding security issues. Maybe I wanted to learn securing them as well. So I started contributing to open source from there onwards, and working for small to big organizations and learning more about infrastructure part, which is my core all the time, and adding as much as security value. Then I got pretty much more interested into cloud infrastructure part. Then that's where I realized how I can use my security knowledge and help or use automation. So that's where I started tinkering with Kubernetes and cloud security, and trying to share my knowledge across the communities and present research. And and a lot of communities help me for sure. Like WeAreDevelopers, I have been involved with the all DevOps, Null, and a lot more other communities.
Yeah. Do you miss the physical congresses as well?
Definitely. One of the main thing I think physical conferences gives is you met a lot of like-minded people, and you learn a lot from them, not just technical things, which I definitely miss a lot.
Yeah, yeah. Do you have any tips for beginners who are watching us, how to start a career in your direction? Anything, maybe any challenges where you had some learnings or some mistakes that you did or some shortcuts?
Yeah, definitely. So one thing I would say is definitely important is when you are starting the career, try to find some good mentor or community where they will help you to grow yourself and build your knowledge. And always try to learn as much as possible in the beginning, because don't be fixed to specific area, because always be T-shaped, like be depth in whatever the area you are interested, and keep breadth of knowledge in all different areas. You don't know, because perspectives change over the time. You might want to later work on different area. So it's always try to learn, as it's easy to switch if you know different things, and always try to teach whatever you know. It's easy to learn more, because if you wanted to teach, you have to be good at that, and be simplified, so you might know better than the other people, right?
Yeah,
So,
that's actually a really important outtake. So don't only learn, but also teach, share your knowledge. I see that you have, or that you are a very active member in the community with your own blog and speaking at several conferences. And yeah, I can only encourage everyone to, submit some talks, to call for papers. We at WeAreDevelopers have also a call for speakers open for several topics all the time, but also, of course, join other conferences, share your knowledge. It's also a good way to get some feedback on your work and to learn something out of it. And Madhu, I see we have a question from Mohammed. He's asking, is there a way to compare golden image layers to incoming deployments?
sorry, can you repeat the question again?
He is asking, is there a way to compare golden image layers to incoming deployments?
Yes, okay. So yeah, the question I think is we have already created a golden image, and we wanted to have deployed another image. So we wanted to compare golden image with the running container or something. So one thing is the manual way, I don't think so. It might be helpful. Dive is definitely one of the useful tools, so that the golden image is the base layer. So you can compare that layer with the running container image layer. So which should be always the from base image. So which kind of gives you that this is the golden image which we have created or used. This is really good, interesting case. Maybe you can create a OPA policy for this. You can create a rego saying that if the base layer is this specific golden image shard checksum, then only allow or use this. I think you can definitely do this with the rego policy.
Okay, thanks for the answer. The next question from DevOrient is, thank you, Madhu. What do you suggest to take care of while migrating to the containers most quick and easy way?
Not
quick and easy is a challenging combination, right?
Yeah, it's definitely challenging, and I think one thing I would recommend is, if you are migrating or coming from the normal data center or cloud world towards containers, always try doing it development level or staging environments, because the main fundamental reason of Docker became so popular, because once you create container in your local environment, the same image can run in your laptop or staging or production, because these all are identical, right? So I think getting started with staging environment and trying locally. And if it works fine, I think it should work everywhere.
Okay, thanks. Yeah, there are no more open questions. Madhu, I would like to thank you very much for joining us and sharing your knowledge with us. I hope to see you in the future again.
Yeah,
Warm greetings to Amsterdam. I hope the weather and the situation there becomes also quickly better.
Yeah.
And yeah, see you next time.
Thank you so much for having me, and have a good day.
Thanks, bye.
Bye.
So, dear developers, that's a wrap up. So we are finished for today. Before we close the stream, I would like to drive your attention to our Python Day in 2 weeks. Looking forward to that one. Make sure to RSVP to this event. You can do this on WeAreDevelopers.com/live. And yeah, will be waiting there to see you again. And if you are looking for a job or you just want to explore the market, then please also visit WeAreDevelopers.com. There you might find some interesting job opportunities in Europe with salary information and so on. And with that said, have a nice evening and see you again in 2 weeks. Bye bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now. Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.